Morning everybody, and welcome to this new webinar by the UK District Energy Association. This morning's webinar is a slight repeat of one we did a couple of years ago with lots of different speakers. It's about delivering high quality heat networks, maximising system efficiency and optimisation. So it's essentially how to create and then operate the best possible heat network you can. So we've got a really exciting set of speakers this morning. We've got 15 presenters talking about different ways they can do this, with an introduction from Gareth from FairHeat about the Heat Network Technical Assurance Scheme. In terms of this morning, in the bottom of your screen, there are two things which are questions and chat. If you have a question for one of the speakers, please do put them in the question session or section, and we will make sure that they're either answered this morning or after the event. If you just want to wish everybody a happy Christmas, please put that in the chat. Please don't put questions in the chat, because otherwise it becomes quite cumbersome for us to manage. So without further ado, I will move on. So today's webinar, you'll all have had this program before, so I'm not expecting you to read it now, but essentially we've got 3 sessions in terms of how you can build and run a high quality heat network. We split them into the design and development phase. So what you need to do before you got the heat network up and running. We then split it in section 2, which is metering, billing and data. So how you use IT to make the system work really well for you. And then we've got session 3, which is operation and refurbishment. So very much the operational phase. And we've got a Q&A for 15 minutes at the end of each of the 3 sessions, and we'll invite the speakers in the sessions to come back and join us on the stage to answer questions about what they've presented. So I won't drown you in PowerPoint about who we are and what we are, and hopefully most people on the call will know us, but if you don't, a little bit about us. So we were formed by 6 founder members way back in 2010. They were largely local authorities, although we've now pivoted to mainly the sort of the full members of the scheme are now largely in the private sector, although we still do have a number of local authority full members. And we were set up as the voice and the network for organisations across the sector. All members are equal within the association in terms they're equally important. Full members simply vote on issues which drive the direction. And to be a full member, you must own or control a scheme. So essentially, you've invested some money, you've got money at risk, or there's something at risk in terms of delivering and running a heat network for you to be a full member. But there's plenty of other people who are not full members. We've got 19 full members, and the balance of the 170 organisations are associate members. So member benefits, busy slide, but I'll just talk you briefly through those. We've got lots of different member benefits. You can be involved in this collective network. That's number 1. We've got 170 organisations. We'll shortly be at 200. 600 individuals we're engaging with. Through us, your voice is heard through central government. We've actually got a webinar this afternoon, specifically on heat network zoning. We've got 100 members attending that webinar. Regularly meet with deputy directors of heat networks, so team members. You've also got in the journal, so we issue that monthly. That's the middle image. That is existing policy, existing things going on in the sector. It's what's happening, but it's also an ability for you to talk about what you're doing in the sector as well. So it's a two-way street, the 50-page monthly journal that goes out. We also have in-person events. We've got our Heat Network Zone at Future Build at the Excel Centre in March, which is now building up to be quite exciting. We'll have a training room there. We'll have networking lunches each day. There's some interesting talks on the energy stage about heat networks. It's a really exciting opportunity. If you haven't already got involved or thought about exhibiting, please do. There's also at the, we're planning a Heat Network Expo in early 2025. The reason that's been slightly delayed is because we'll be doing that in partnership with DESNZ. So we're targeting 50 exhibitors and 400 delegates. So this will be the first time ever in the UK there will have been a Heat Networks Expo. So that's really exciting. There'll also be another opportunity to win a UKDEA award. Also involved in our regular working groups. We've got working groups on counterfactuals, sleevings, all manner of things. Speak at one of these webinars. We typically have 200 people register for these webinars. We've got the library on the website. You can access that. There's well over 500 documents. Most of those are really hard to find and not even published anymore. You can ask for member meetings. So, as I often say to members, I know an awful lot that's going on through the sector simply by virtue of the position I hold as chairman. And anything that's in the public domain, happy to talk to you about. There are jobs boards, you can advertise your jobs for free. There's a training register as well, where you can put your training in. And the new initiative that we're just finishing, every member will be part of the Heat Network Specifiers Guide, which will be launching early in 2025. Tom is just, our secretary is just finishing off all of the entries at the moment. Essentially, we're a network of members working together to assist each other and a voice for the sector. And there's a nice little attestation from Jodie Pittaway from SSC at the bottom there. And just to encourage you to think a little bit more about considering being a member. The membership fees were set up by local authorities in 14 years ago, so they've only indexed up for now. They're incredibly low, so for almost everybody on the call joining as an associate member, it's only £810 per year. So it was never meant to be a barrier for membership. So without further ado, I will stop talking and I will invite Gareth from FairHeat to come onto the stage. Gareth Jones is the Managing Director of FairHeat, and Gareth will give a HNTAS update. And over to you, Gareth. Thanks very much indeed.
Thanks a lot, Simon. Good to be here today. Thanks a lot for the invite. So got a couple of hats on today. So I'm, as Simon mentioned, I'm the Managing Director of FairHeat, but I've been the technical lead, so for FairHeat, with the technical author of the Heat Network Technical Assurance Scheme, and I'm actually here with a DESNZ hat on today. You know that all the slides are DESNZ branded, to give an overview of the Heat Network Technical Assurance Scheme, which the program's been running for a couple of years now. So what I'm going to do, really try to do quickly in 10 minutes or so. Simon thankfully gave me a couple of extra. It's just run through some of the introduction, go through vision and principles, and then talk through the structure itself, scheme characteristics, and then touch just very briefly on assessment and certification and existing networks. So I'm going to cram a sort of a half-hour presentation into about 10 minutes. Very quickly, in 2020, Ben Bay's consultant in developing a market framework. As part of that, there was a lot of support for introducing mandatory minimum technical standards. And off the back of that, it was put forward to develop a Heat Network Technical Assurance Scheme. Changes coming off all of the back of that, regulation to launch soon, so in 2025. That's going to require certification based on outcomes, so KPIs for heat networks, so minimum technical standards. And this includes all new build networks, so some in the order of 50,000 residential connections per year, but it's been higher in the past and we expect it to go higher again, and existing networks. So something in the order of 14,000 networks with something in the order of 500,000 residential customers. Includes communal and district networks, and alongside all of this, there are other changes to include customer protection and zoning. So I spend quite a lot of time on this. This slide sets out the vision, aim, objectives, and core principles for the network, for the scheme. There was quite a lot of time spent on developing this, and early on there was a board formed of Ofgem, DESNZ, ScotGov, and Heat Trust. The one thing I will pick out is the aim, which is develop a heat network technical assurance scheme that ensures a minimum level of performance and reliability for heat networks in the UK. And there are a couple of specific elements of that. It's a technical assurance scheme. An assurance scheme has a number of characteristics, so there is an assurance element within that. And then when we're talking about minimum level of performance and reliability, what that's talking about is setting a floor, and it's very much a pass-fail. So you either meet that requirement or you don't. So it's an assurance scheme to whether or not you meet or don't meet minimum technical requirements. Underlying this, there are a set of core principles which have really governed the whole scheme development over the last couple of years. The first of these is that the scheme is to be outcome orientated. It's very much focused on performance outcomes rather than process. So we're trying to assure the heat networks perform in a certain way rather than gone through a certain process and development. That they're preventative, so it's very much, this is not supposed to be a punitive approach. This is very much about saying, okay, here are the key failures we're seeing in the industry. Where are the decisions made that lead to that key failure? What decisions and what checks need to be put in place, checks and balances at that point to ensure that that key failure then doesn't manifest itself later. It needs to be proportionate, so balancing effectiveness of assurance against cost of compliance. And then there actually has been a lot of time looking at making sure that it's deliverable. So as much as possible, basing on existing processes, fit with existing contractual and delivery processes, and then really looking at market capacity and the regulatory framework. And there's been quite a lot of change to the scheme from initial concept through to later concept, governed by this whole deliverable principle. The scheme needs to be adaptable. We need to take into account that the industry is maturing, and as it matures, some checks that might be relevant early might actually be pulled up, and we need to be adapting over time. And it also needs to be enforceable. So very much the underlying principle is you should be better off following the process and complying rather than not complying. We could spend a lot of time on the regulatory framework and governance. We're not. I've just got one slide very briefly. Under the Energy Act 2023, Ofgem will be the regulator of heat networks. Under the Energy Act, Ofgem will license a code manager to maintain scheme code documents. So this is for heat networks, Heat Network Technical Assurance Scheme, so HNTAS. Those code documents include a technical specification, which sets out what heat networks must comply with. It sets out assurance procedures. So again, this is a technical assurance scheme. So how responsible parties demonstrate compliance with the technical specification. And it also sets out assessor requirements. So who can assess compliance and what processes do they need to have in place. So those are the three core documents underneath the code. With regards to scheme characteristics, there's a lot of work that went initially with respect to how do we put into place a assurance and certification scheme, which we'll come on to, but an assurance scheme for networks which are developing over long periods of time, where you might have different commercial interests who actually manage different parts of the network. So where we've got to is that there are 6 distinct elements within the assurance scheme, and those get assured. Assurance is actually based at an element level. So energy center distribution networks, which are split into either district distribution or communal distribution. Effectively, communal distribution is everything within the building. District distribution is everything outside of a building. Predominantly is going to be buried networks. Substation, so connection between distribution networks. Customer connection, so connection to the end consumer. And then consumer heat systems. So those are the heating, cooling, hot water systems within the consumer premises. On this last point, this consumer heat system is within the scheme for new build development, so new build buildings, but it's outside with regards to ongoing management, regulations. So individual heating systems within dwellings, for example, are not regulated. The technical specifications, effectively we have a technical specification for each of the different elements. So for energy center, district distribution networks, communal distribution network, substation, consumer connection, and consumer heat system. And then those are then split by stage. So we have different stages through time. So we have, at the outset, we've got concept design, then we go into design, go into construction, operation, and then ongoing operation. I won't go into a lot of detail within the time frame today on how that sort of split works, but effectively the idea is for each of those different heat network elements, at a different stage, there is a single document that whoever's involved in that stage can take and read what the requirements are at that point in time. With regards to the scheme itself, as mentioned before, it's an assurance scheme, it's performance-based. So there are independent assessment of claims made by a responsible party as to whether minimum standards will be achieved. So this is the idea of prevention. This is validation of a claim against a future state. Will this design achieve this performance outcome, or have they been achieved? So verification, things like acceptance testing for identifiable elements of a heat network. And all of this is to ensure that certain performance outcomes are achieved and maintained. So again, very much this performance-based approach. There's then certification that performance outcomes are being achieved at the end of commissioning, at the end of initial 2-year operation period. So this brings us on to assessment versus certification for new build schemes. The rationale behind the assurance scheme structure is that at the end of construction phase, Ofgem very much wants a binary yes-no decision as to whether technical standards have been met to inform authorization of heat supply. There's a real risk if we just put in a certification scheme at the end to say, has it been met or not, that current market practices would lead to a proportion of networks failing to meet certification. And there's a really strong desire from DESNES that networks do not fail to get certification. So what we need to do is put in place a structure to ensure that right decisions are being made at the right times through an assurance scheme for the development of a heat network. So validation of design and verification of installation and commissioning. So effectively, what we have in orange is an assessment program. So we have assessment by assessors at different gateways, so through concept design, developed design to technical design. Developed design is optional, whether or not that goes through at that point. Then in construction, so we have construction design, installation and commissioning. At the end of that, there's another gateway, so the 1, 2, 3, 4 gateways. And at the end of that construction phase, so the end of commissioning, that gateway there is the first certification stage. So effectively, that's where we get third-party certification, whereas everything up to that point is through an assessment framework. There's then initial 2-year operation period in which there's still assessment before we get another certification. Post that, we actually move on to a totally different regime where we just get reporting of KPIs. So reporting of KPIs, and that's just an escalation process in the case that things go outside of the bounds. Very similar to other schemes, we're going to have, so people who are familiar with the Building Safety Act will be familiar with this. So we have different duty holders. We have, during design phase, designated designer. During construction, we have designated contractor. And then operation, we have a designated operator, all underneath a responsible person. And then we have a HNTAS coordinator above that, responsible for pulling together all the documentation. Existing networks, and I realize I'm going through this at a canter, but there's appreciation that existing heat networks will find it a lot harder to meet minimum standards, particularly at the outset. So we've got a 2-stage transitional approach. At the start, we're going to require minimum levels of metering and monitoring to be installed, so there's visibility on performance, and we'll require reporting within a relatively short period of time. We're then going to have an absolutely minimum threshold performance, which needs to be achieved within a relatively short period. And then operators need to set out an improvement plan, so performance improvement plan, setting out how they're going to achieve certification within 2 minimum standards within a longer time frame, which I'll again come on to. And this is a different approach that's going to be required for those networks which have already got metering in place, which have metering in place under the meter and billing regulations, versus those who didn't, because there's appreciation it will take time to install metering. You then have to prove input use performance after 2 years of operation based on real data. These slides will be distributed, but very quickly there are different milestones. So milestone 1 is to register the heat network. Milestone 2 is to demonstrate you're meeting minimum metering and monitoring requirements and meeting threshold performance. Milestone 3 is to submit a heat network as a performance improvement plan. And then we have milestone 4, which is certification, milestone 2, which is ongoing certification. The years at which those get applied really depend on whether or not there was a requirement to install customer level meters, in which case it's earlier. So you'll see that certification is in year 6 for those networks, whereas those networks which weren't required to install customer level meters, and you see that certification is actually in year 8 at this point. There is a point that is in milestone 3B, in which that there is metering and monitoring for all end user connections required by year 5. Again, one thing I just need to note, all of this is proposal. It hasn't gone through consultation yet, so this is just direction of travel and thinking at the moment. Tentative time frame for end-of-life networks. We recognise there are quite a few networks out there which are going to need to be, which are probably nearing the end of life and will come to the end of life within this framework, within the sort of 10-year period, would be that you register your heat network, and then by that sort of year 3, you would declare as an end-of-life network. Otherwise, you're treated as an older network, and then you'd come through and by year 5, have to go through for a new build perspective, have your stage 3 design statement of conformity, and then effectively you go through certification by year 8 and year 10. Again, this is all tentative, it's all still in development. Next steps, current status, we've got a shadow service provider in place for pilot phase, that's GemServe, being supported by FairHeat. We've got new build normative documents drafted, works underway to develop all normative documents for existing networks. We've got 14 pilots in the pipeline, so there was a procurement for 4 pilot assessor organisations. That was through competitive tender. Just to flag, we've already been asked this question today. The intention is there will be a lot more assessors coming into the market, and a positive desire to have more assessors coming into the market. Pilot trainings effectively coming up to completion, but there will be further training being developed, and that will be being launched out to market with training courses in mid-2025 for different roles, including for assessors. Work's also underway in parallel to develop a new heat network technical standard, which will effectively replace within the technical specification, supersede CP1 2020, with that also being launched in 2025. I'm out of time, so these slides will be circulated, but very briefly, consultation coming up early 2026, within the scheme coming into force sort of early, so at the start of 2026. Sorry for having to do that all at such a canter. Simon, I'll hand over to you.
No worries at all, Gareth. Thanks very much indeed. Much appreciated for recognising you need to keep your time, but a really interesting one. There's some questions already appearing in the chat. Please, if you want to ask Gareth a question, he should be around for the Q&A later, but if he's not, please do put the question in the Q&A. I will rapidly leave the stage and hand you over to Stephen Hart, Director of Integrated Solutions for Baxi, who will look at the considerations when designing heat networks. So over to you, Steve.
Thanks very much, Simon. Okay. Yeah, so I've been involved with heat networks accidentally since 2004 and on purpose since 2008, when we were importing and distributing heat interface units onto the market in the UK and Ireland. It is true to say that the quality of HRUs have improved drastically over the time, particularly since the first beta test was introduced in 2015. And again, the version 2 of that in 2018, and finally the version 3 in 2023 in the October. And actually the beta test now sets a pass-fail standard for heat interface units and also identifies best practice passes. So the bar is definitely raising, and that's stimulating innovation and improvement amongst the manufacturers participating in the market. We've also seen the commissioning checklists and standardization of commissioning under the code of practice. I think that'll continue to happen as Hintas takes over from CP1. What we also have seen in recent years is whilst metering and billing has consistently been important, there's an increasing appetite for connectivity, for predictive and preventative maintenance, and remote commissioning, and particularly ongoing optimization of networks. There's been much discussion in the past about whether HIU should be mechanically or electronically controlled, and actually both can work extremely well. In fact, the company Baxi, we're part of the BDR Amer group who acquired Fortis Energy Systems, the Dutch leader in HIUs at the beginning of last year. And they first qualified their AquaHeat HIU under the 2025 beta test. And now Baxi supply that AquaHeat HIUs in the UK and Ireland under the Baxi AquaHeat brand. But Fortis themselves originally started manufacturing mechanically controlled HIUs in 2001, and they did work very well. But certainly they commenced a transition towards electronic control in 2015, and now all of the HIUs that emanate from our factory, which is about 44,000 units, have electronic control. And we kind of are aligned with that approach because we think that allows for many more smart control functions than perhaps a single self-acting unit. So I won't go through this table, but these are the various features and functions that the electronic control, which has evolved. I think we've got the TR4 controller, so the 4th generation controller now. I'll just forward on here. So somebody else having a little go on the keypad here. But some functions that I'd just like to point out is we have machine learning, and that both learns the optimum set points for valve positions, which enable a fast reaction to get onto temperature, and that's just using historic data, and can change depending on supply temperature and etc. And but also we have certain keep warm modes where the unit can identify the optimum trickle flow to enable you to get the heat off of the plate in 10 seconds and not too soon, otherwise you're trickling too much heat, and not too late, otherwise you're not doing comfort. And that can be different for different, even the same type of HIU in different parts of the network. Other things in there, a secondary supply temperature compensation, and that ensures when it's activated that we have return temperature limitation, can be very important, maintaining those low. And even we can supersede that with delta T control, which would allow purposeful variation of primary supply temperatures, let's say a summer temperature reduction or weather compensation, but still allow us to work with the design delta T. And all the things are available because of the algorithms that are in the electronic controllers, and other things, integrated capacitors that close the control valves if the power fails accidentally, or if somebody leaves on holiday, or perhaps on purpose if it's associated with some prepayment type systems. So we have really gone this route because of the increased functionality. One of the things to really note, however, is the hot water control has changed drastically. At one point we were having to deliver 70 degrees primary supply temperature onto HIUs to use maybe a 10 degree approach temperature, so that the thermostatic self-acting controls had enough power to regulate. Now with electronic controls, we can narrow up that approach temperature, and recent thinking, particularly when there's no storage in the system, now allows us to deliver heat off instantaneous hot water plates of 50 degrees C, which does allow us in new systems to design just down to 55 degree primary supply temperatures, and that enables us to deliver what's required off of an HIU with regard to domestic hot water. One of the things that we agree on the right hand side here is that back in the days when Baxi were delivering boilers into multi-occupancy dwellings, they would be placed on the external walls because there had to be a flue getting rid of the gases. More recently, of course, with HIUs, it now means HIUs are typically placed local to the entrance to each of the apartments, and you can see that middle picture there is a single riser to multiple apartments, and you can see the length of those laterals are getting smaller, and the pipework inside the dwellings getting shorter. And if you go to a kind of a multiple approach, multiple risers, you can really reduce down the length of those lateral pipeworks, preventing that kind of overheating in the dwellings themselves. And that means that we can use selectable different approaches onto keep warm. We can turn it off altogether, We can have something similar, with in frost protection, so it is off, but perhaps starts to circulate if minimal temperature of 5 degrees reached. Very useful through the construction phase. In particular, the eco setting is pretty smart. This means that the unit will search for seeing that. It draws the conclusion that perhaps the apartment or the house's dwelling is not occupied, and will set back to the off mode until such times another tapping is made. The dynamic control in particular is important, and that's the one that regulates the trickle flow in order to maintain that optimum balance between reduced energy consumption in that kind of standby mode and the ability to deliver heat and hot water quickly to get comfortable. Although we've gone through the beta testing, we have to set our sort of smarter settings onto comfort, i.e. a standard 45 degrees set point. And that's simply because the beta test is unable to review what's going on. So this is just another way of showing that multiple riser approach. Here you can see that we've got a typical communal heating system where we've got some hybrid heating, with air source heat pumps typically delivering 85% or so of the annual load, maybe some peak load boilers delivering in the remaining load on the coldest day, and we find this hybrid approach really reduces the sort of the capex and also the DNO for the electrical capacity you need off the grid. Interestingly, on the left-hand side, we're showing a single riser, traditional pipe work, and you can see those long laterals that have to run down corridors and have a tendency potentially to get overheated. But so on the right-hand side, this is a sort of illustration of a multiple riser approach and how short those laterals to the HIUs can be. And if you get them short enough, you can turn off those trickle feeds to those heat HIUs. The only thing that you must then do is make certain that you install a thermostatic temperature control valve at the edge, at the top of each riser, so you're maintaining heat in the riser, so when the HIU cools, it can go. And I think a little bit more on the test regime, which is now a modular type approach here. So that we've got lots of different types. They're now supported and set out by the new British standard that's now available since the summer. But of course, the twin plate unit has been very, very useful. One thing to finish with here is I'll talk about that. Make certain if you're using tested units, then you're able to use lower numbers for your Part L calculations in SAP. And I think for the sake of time, we'll do that, Simon. I'll notice you on the stage. Thank you very much, everyone.
Brilliant. Thanks very much indeed, Steve. Much appreciated. Thanks very much. So if I invite Steve to leave the stage and Stephen Hayes to join from Nordic Energy, that'd be great. And we'll pull. Excellent. Brilliant. Thanks very much. So Mark and Steve, over to you.
Okay. There's Mark joining the stage. He was going to open this up. If not, no problem.
I'll leave you to it, Stephen.
Yeah, it looks like I've been deserted, but it's fine, Simon. Thank you. Can you hear me okay, guys? Yep, great. I'm just going to try and share my screen because I'm going to give you a live demonstration of a tool that we are developing and bringing to market. Just give me 1 second. Oh, dear.
I managed to join, so apologies everybody, misunderstanding the instructions. So just to explain that what Steve's doing is while he's loading up the modelling, it's a demonstration of our heat network module from the Ener-Vate UK Net Zero Living programme, which is part of a suite of modules that covers not just heat networks but also solar, wind, heat pumps, retrofit and EV charging. So over to you, Steve, for the demo.
Okay, let's try this again. We've got a pre-recorded version if need be. There we go. Can you guys see that okay? Yeah, excellent. Yep. So what I'm going to show you here is a tool that we've developed as part of what Mark's just highlighted. We're bringing this to market soon, and this really, what we're aiming to do here is effectively lower the entry level to understand what the opportunity for district heating is in certain areas. And really we're aiming towards kind of the REBA stage 2 piece here. And this is very much about understanding, where do we start with heat networks? What can they mean for our city, our area that we're responsible for? And I've got a demo here. And this is Peterborough that we're going to do this in. What you can see in yellow there, that are the that's the zoning areas for Peterborough from DESNZ. We're involved in creating these. So I'm just going to try and kind of whistle you through this quite quickly, given the time constraints. So what we have is every building within Peterborough in here. You can see it there. You can click on any one of these buildings and it will tell you what that building is, what kind of category it is in terms of its heat use, what those key metrics are in terms of heat demand. And that peak demand, that exists for every building. It can be the residential ones or the commercial ones. For the point of exploring this zone opportunity that I'm going to do now, what I'm going to do is apply a filter because we're interested in those that are required to connect. And you can see a bunch of purple disappear as we've just effectively selected everything that has that demand profile. So what we need to do is we need to set a heat source location, and with the 3D view and context that we're going for here, we can kind of see where it's available. I might know that I can place one in around this field here. So we've got a red dot roughly within that vicinity. That's our heat source location. We can select the zone. This zone is referenced as Westwood. We can select the buildings within that zone. So we have 29 connections here, if you look on the top left. Hopefully you can read that, and a total peak demand. And we can set some settings within here. I've pre-configured it to say that we're going to put a biomass boiler 11 megawatts. There's different plant types, fuel types you can change here. You can do a bunch of sensitivity around those assumptions, those parameters, and then you simply hit create heat network. Now what it does is it takes that location, all these different buildings, and it works out a sensible way of how you would connect these to a district heating network. It does that, then it also does some hydraulic analysis to kind of work out how big the pipe network needs to be for you to deliver that energy, and it will also do a commercial analysis. And you can see that me, with a few clicks, has kind of got this view back within seconds. And if you look on the left, hopefully you can see that we've got some different pipe diameters. We have different lengths of that pipe requirement. We have some high-level commercial analysis figures. So we've got the IRR, the NPV, and the CapEx, and this is all based on a detailed techno-economic model. We can zoom down in, explore this within this mapping environment. We can click on any particular of these pipes to understand a bit more of the details around it, so we can see how much is hard dig, how much is soft dig, and the energy requirements associated with that pipe work. Now that's all very well and good, we've got a good view very quickly. But what we might want is to apply our local knowledge, our local context. So if I just clear that, we have another way of building heat networks within this tool. So I'm going to go over somewhere different now, just to demonstrate this. So what we're able to do here is, again, we'll click this edit view. We'll set a heat source location. What we have now is on the right, you can see this kind of more 2D view. And this is the Ordnance Survey kind of backdrops, which pretty much make up for all those technical drawings that you kind of see. And then we have on the left the 3D real world scenario kind of situation on the right. And now what I can do is literally draw a heat network from this point. I'm going to say, right, I want to connect this building. So I'll double click and connect that building. You can see on the left, that's represented now in terms of that pipe network that I've drawn. I might say, well, okay, I'm ready to draw, extend from here. I want to go down this way, up this way. And then you can kind of zoom down here and say, well, actually, how do I connect this building? I might know more details about this. I might know where the plant room is. And so actually, if I go in this way, I might be able to go through this scrubland here without too much trouble, across into site, and then into the building. And I might know that their plant room's there. So it's, again, you can just press the run button effectively after this, and it'll generate all those commercial inputs based on the assumptions that you fed through. So you kind of get this real good oversight, really, both being able to do that kind of detailed route planning, as it were, as well as an automated kind of opportunity framing exercise. We have other information in here to assist. At the moment, you can see the zones. If I turn that off, we have the dig area. We can kind of go over anywhere, and you can see what is classified as soft dig and hard dig within these areas. We also have, if I just flick this one on, off, we have the land ownership. So you can quite easily click anywhere within Peterborough, and what you're able to do is kind of see who owns this land, and you've got the address information associated with it, the title numbers, so you can see whether it's public, whether it's private, what kind of it informs you really. Do we need way leaves, easements? Is that a good way to go? Is it not? And it kind of just helps kind of inform you in advance as you're kind of building these to make it as robust as possible for the later stages. So I think we're kind of nearly out of time. There's a lot more I could show you with this, but I think just to keep it brief, that's what we have. And you have the ability as well to export all of that commercial information, the detailed techno-economic model and spreadsheets, and play different tunes with that to help inform your decision-making process and your opportunity framing.
That's brilliant. That's a really, really exciting piece of software. Thanks very much indeed for showing us the software live. That's very helpful. Thanks very much. Delegate,
it allows me to bring the time down as well, Simon, doing it live. Yeah, I can adjust it.
No. Fair play.
Fair play. Another minute. So
I was watching with fascination at that. That was brilliant. That was really good. I'm sure there'll be lots of interest in what you've shown us there. So thanks very much indeed to Mark and Steve. I'll now invite Rodrigo from AECOM to come online and to talk about heat network development from concept to successful commercialization. So Rodrigo, over to you. Thank you. Just want to test your mic, Rod.
Thank you very much. Yep. Can you hear me?
Perfect. Definitely. Lovely. Thank you very much.
Thank you. Thank you very much. Good morning, everyone. So we're going to be talking about development of networks from concept design to successful commercialization. Some of the lessons learned. This is obviously a topic that could take us a long time to talk about. We could be here for a few days talking about this, but today I'm going to be talking about some of the specific roles that are involved in this process, especially in the early stages, and try to give you a bit of information on some of the lessons learned that we've been through in one of our projects. Just to set a bit of context, since 2013, when HNDU was created, we've seen the public sector leading most of the district heating schemes. However, in the last couple of years, we've seen a much more higher share of a much more intense involvement from the private sector into this scenario, and despite having a very clear, well-defined process for developing these networks, these projects in the early stages, what we've seen is that there's a bit of confusion in some instances on the different roles that the developer and the other parties involved should be taking, and most importantly, how those roles evolve throughout as the project moves along on these areas. So and also we've seen the typical example of a local authority that is over optimistic but with limited resources, and all this leads to more time invested in developing these projects, and obviously an increase in costs. To go on to just to define what I'm meaning about early stages, I'm not going to be talking about this diagram. Probably you know it much better than I do. This is a fairly standard representation of the process of development of a district heating scheme. I'm going to be focusing on the feasibility, the detailed project development, which is effectively when we create the business cases, and the commercialization. That's what I refer to early stages. This is obviously the timescales we have here are intended for public sector developments or tentative timescales. Probably if it's a private sector led project, these timescales will be much quicker, but ultimately the format and the process, the skeleton of the processes remains valid for both cases. Now, when we talk about the well, before jumping into the roles, I mean, we had this case of a heat network in the north of England, where they had a project that had been in the making for several years. It was a typical story of a project, you know, an initiative that has been, you know, iterated in several forms by different people, by different consultants, different administrations, and most importantly, as and when funding was available. The council had really good aspirations about how they wanted to see the network happening, but really limited resources, and most importantly, they had very significant conflicting priorities in terms of decarbonization, especially when you're talking about a smaller city, a smaller local authority. It becomes really difficult for them to prioritize certain activities when they have very limited resources. What we've seen is that net zero in many cases is not enough to justify. They have to have political and institutional backup to drive these projects forward. And in this case, it was in this particular case, there was an ambition, but it was not properly reflected in maybe the corporate plan from the council or the council's manifesto, things like that. I will argue that this is probably a true setting for a lot of towns in across the UK. So what we've seen is that one of the issues we had there is that there were not very clear. There was not a very clear definition of the different roles of the people or the parties acting in this project. So the ones I'm going to be concentrating in this talk is about these five roles. You can argue there are many more. Absolutely, there are many more roles that will interact in to make a project, heat network project, or to develop it. But specifically, I'm going to be talking about these roles and how they translate or how they evolve. The project sponsor, effectively before the procurement process, and by procurement, the early stages I was mentioning before, we have the feasibility and the business case integration. And then we have the commercialization. I split the commercialization in two stages because that's where the transition is, the main transition between the roles is. Because during the commercialization stage is when we will be procuring a delivery partner. What we've seen is that the scale of investments that is required for these projects is not available in the public sector. That is one of the reasons the private sector is joining into earlier stages, because they will be taking over the construction and the delivery of these networks, and it is at the procurement stage where that transition of roles happens. The most importantly, the project sponsor is the one who decides on the route to market. One of the things that Danfoss has been working quite actively in the last couple of years is developing a standardized system or a standardized set of documents for different routes to market to minimize time and costs for local authorities to access the private sector, and the private sector to access to very good quality projects. So effectively, this project sponsor in those initial stages takes the role of the CEO, is the one who's making all the decisions, the one who's deciding the route to market, and after the procurement stage becomes a board member. We have the project developer, which you could argue is some sort of the operations officer, the chief operations officer in the initial stages, and then after the procurement takes the role of more of a PR manager. We have a project manager, which is kind of a constant. Is that party that is always making every work stream work together. And you'll have that role before and after. However, after the procurement, once the private sector takes over, is likely that role will be absorbed within the operation of the network. And finally, the customer and the role of the customer. The reason I'm putting it here is because in many cases we've seen local authorities covering all those four roles, and it's absolutely fine. A local authority or a private-led in a private-led scheme One single entity can cover all those roles. However, it's really, really important for us to have a very clear distinction, specifically around the project sponsor and customer, because both of them will have very, very different financial implications. So the heat network customer before the procurement is, you could argue, it's some sort of a window shopper. It's a stakeholder, a major stakeholder, but it's not until after the procurement when there is a a financial implication into the delivery of the project. And the delivery partner, which initially takes a role of a stakeholder, a major stakeholder, then after procurement becomes the you could argue becomes the CEO of the network. Some of the lessons learned that we had in this project, in this setting I was mentioning before, specifically around the governance. Although, first of all, we didn't have that definition that as clearly as we should have had it before, so there was a bit of a mix and match on those roles, and that led to not having a proper governance in place, and most of the decisions around the heat network were directed or channeled into the existing decision-making mechanisms of the council, which they tend to be not fit for, well, they're not fit for purpose in the dynamic context of the development of a network. So that led to obviously longer times, lots of waiting times, and a lot of a lot of expense in trying to get decisions when they were really needed. As mentioned, the roles were not necessarily clearly defined, so the sponsor did not really understand what was needed of the project of what was needed of the sponsor as the project was evolving very quickly. That definition of the roles came in a bit too late. External advice. We didn't have enough external advice early enough in this project. So when you, specifically when it's a very dynamic project, it's a changing landscape on a regular basis, and there is not enough in-house capacity. It was even more complicated for the council to make those decisions that were needed. Therefore, engaging with legal and commercial advice early in the process, it was absolutely, it will be very, very beneficial. One thing that we learned a little bit too late was to properly engage with the market at later stages in commercialization. The initial thought around this was to go to the market with something much more prepared, something like a proper design, and the response from the market was that they wanted to be involved much sooner. They probably won't need as much detail as we were expecting to provide them with, and that was probably one of the most important lessons that we learned. Involve the market quickly and as soon as possible. There is a big constraint there's a bottleneck in the supply chain, the market in later stages. So private developers are really keen to get involved as soon as possible to make sure they understand the projects properly, and then they have the necessary elements to bid for the project and to take it forward. And finally, one of the biggest lessons learned as well was about the local champion. We did not have a proper local in-house champion that was pushing the project forward on a regular basis. So that is crucial for this type of projects, to have the local champion to help you move the project ahead, even after the engagement with external consultants. It's slowing down. But anyway, as mentioned, it's a very, very broad topic, and we could be here forever talking about it. But hopefully you find this interesting and useful.
No, thanks very much, Rodrigo. That was really, really interesting. Thank you very much indeed. Please stay around for Q&As at the end. If I could invite the next speaker to come up on the stage, we've got Kneale from Solid Energy. He's Business Unit Director for UK and Ireland, and Ken will be talking about innovations in heat pumps. So thanks very much indeed to Rodrigo, and over to you, Ken.
Good morning. I want to talk about heat pumps in energy centres and substations. I've got quite a few slides. I know that they're going to be distributed, so I will be flicking through them quite quickly. Solid energy, we come from Denmark. We have a number of heat sites over there where we joined up with the networks. We've moved from ammonia onto hydrocarbon. We've been running now for over 10 years. We're still a small company, but we're nimble enough now to adapt to the needs of the UK market. There's some of our recent projects. You'll see they're all multi-megawatt. The last one down at our house, 10 megawatts water to water heat pump, which is actually using our new modules, which I'll be talking about. And we've got recent installations in the UK, London, and Dublin, Plymouth, and Hebburn up in the northeast. So our heritage is really Danish, a totally different market to the UK. We've learned some lessons in the last few years. In Denmark, the assembly is very much on site. These are large installations, so rather than assemble in the factory and then having the logistical problems of moving to the location, we build on site. That's just a typical Danish site, plenty of land, no residential properties in the area. Although we're concerned with noise, we're not as concerned as if that heat pump is in the middle of London. Neither are we really worried about where the cold plumage goes. It just rolls across the fields. So we've got lots of different issues to resolve in the UK. That's the inside of an energy centre in Denmark. The heat pumps, the compressors are all inside noise attenuation enclosures. These are now very different to what we're actually going to bring into the UK. We've gone for a modular concept because what we want to do is to test the units in the factory. We've gone for 4 hydrocarbon refrigerants and 7 different sizes of compressors. And what that means is that we've got a huge range of flexibility with both the power output of the units and the temperatures that we can achieve. I actually can't tell you the details of that unit. That unit on the photograph, it could be an 800 kilowatt heat pump that's developing 65 degrees, or it could be an 800 kilowatt unit that's developing 150 degrees. The only reason I can tell it's approximately 800 kilowatts is because I can see that it's quite a large compressor. The compressors are the heart of our heat pumps. They have very low maintenance. They're designed with a lifespan of 100,000 hours. There's no oil change. And we've just got 7 sizes. The secret of the advantages here, though, is the range of the 4 different hydrocarbon refrigerants. We go from propane, which can go up to 65 degrees, through isobutane, butane, isopentane, which can go up to 150. The units are identical. The only difference is the refrigerant inside the compressor. This is an illustration of the working envelopes of the 4 hydrocarbon refrigerants. So we can go from low temperature in stages right through to the high temperature. And the great thing is that we're keeping the same pressures in the compressors. We are not putting anything under strain. We're using the advantages of the refrigerants to generate the temperatures that we need. So for the heat pumps that we're now bringing into the UK, we've got simplified installations. We've got no loose components. There's no specialist welding on site. The thermal transfer fluid from the evaporators is brine. We're not using direct refrigeration. They're all factory tested before they leave Denmark. And of course, what that means is we can improve the production techniques and reduce cost. That's what a module looks like. All the same dimensions, 3.7 meters long, 2.8 meters high, 1.4 meters wide. And we can have one unit for a small heat pump, or we could have multiple modules to go up to 10 megawatt and beyond. That's what they look like. Although they're designed for the UK market, they've also now been very popular in Denmark. The factory is fully occupied now for the next few months, making orders for both UK and Danish contracts. Standard unit, all wired, all the controls are in place, fully tested in our new test facility, and all EN 378 compliant. If we're going air source, the module on the left is now used for splitting up the feed to the evaporators. We bring out a flow and return from the heat pump to go out to the evaporators, but that is actually divided into 4 so that we can defrost 1/4 of the evaporators without a huge reduction in power output. And the other pump units now that we make in the factory, they are for water source units. So we can use the same compressors for air source, and we can use the same compressors for water source, and if needed, we can actually combine the two. One example is the unit up in Hebburn that was designed as water use, and it's also running now on air source. So there's some photographs of the completed pump and valve units. To be able to select the right combination of compressor size and refrigerants, we've got our performance calculator. We can declare the COP, and we're very happy now to make sure that they go into performance guarantees. That's a unit under test in the factory. We've no concerns about bringing them into the country pre-commissioned, ready to connect to the electrical and pipework systems and set off. That's a typical 1 megawatt air source heat pump. We use that illustration to emphasize the space requirements for the evaporators. For 1 megawatt, we're talking between 80 and 100 square meters of footprint. There's some advantages of our modular design. And one problem that we have got is that we can now use one of these units to overcome the problems of substations, and we can take water at 60 degrees and take it up to the temperature that's required. We just run an award at the recent H&V News. We were very impressed to see that we'd beaten some really stiff competition. We have a distributor in the UK now who is supporting us. Thank you, Simon. Did I overrun that?
You almost, but don't worry, Ken, we won't fall out over it. I thought your final slide about higher temperature heat pumps were very interesting, so I was keen for you to show those. So thanks very much indeed, Ken. Much appreciated. We'll ask Ken to leave the stage and invite Andrew Sims from Ratmon, which is a new business venture to come online and to talk about leak detection solutions for heat networks. So let's just that's it. Good, excellent. Andrew, do you want to go ahead and then I can make sure we can hear you?
Yeah. Good morning, everyone.
Perfect.
Excellent.
Lovely.
You can hear me. Good stuff. Today I'll be talking about leak detection systems in heat networks. Heat networks are critical infrastructure transporting thermal energy from a central source to multiple locations. These networks are highly efficient when operating correctly, but their complexity makes them vulnerable to issues such as leaks, which can undermine performance and cause significant disruption. This is where leak detection systems, or LDS as we'll call them, play a vital role. Why have leak detection systems on heat networks? Leak detection systems are designed to maintain the operational integrity of heat networks. These systems provide continuous 24/7 surveillance, ensuring that even the smallest faults or leaks are detected early. By automatically notifying operators, pinpointing the location of leaks, and providing detailed monitoring data, leak detection systems empower teams to respond quickly and effectively. This minimizes downtime and keeps the network running smoothly. So what does this ensure? Leak detection systems deliver a range of critical benefits for heat networks. 1, operational efficiency by preventing energy losses and optimizing performance. 2, continuity of supply, ensuring customers receive uninterrupted service and heat delivery. 3, enhanced safety, identifying potential risks before they escalate into major issues. 4, sustainability, reducing waste and environmental impacts such as emissions or water loss. 5, infrastructure longevity, extending the lifespan of the network and reducing the need for costly repairs or replacements. Without leak detection systems, these networks are exposed to risks such as energy wastage, infrastructure damage, and customer dissatisfaction caused by supply interruptions. Leak detection systems are not just an operational enhancement, they are a necessity for reliable, sustainable, and customer-focused heat networks. As the UK transitions towards net zero, heat networks are taking centre stage in efforts to decarbonise heating. By 2050, the government aims for heat networks to meet 20% of the nation's heating demand, transforming them into a critical utility for cities and towns. This rapid growth is underpinned by substantial government support, whether it be funding, guidance, or regulation. Improving standards is pivotal to the growth, and there are documents to assist you, such as CP1 and the new set of technical standards that heat networks, both new and existing, will have to meet through an accreditation scheme. Owners of heat networks will need to bring existing heat networks up to a higher standard, and part of this will include that there are surveillance systems in place to monitor the buried pipes to avoid unnecessary leaks or outages, which could have been avoided. The evolving market makes the role of leak detection systems even more critical. As networks scale, leak detection systems become a foundational component for maintaining the integrity of this infrastructure. They are essential not just for addressing immediate operational concerns, such as preventing energy loss, but also for enabling the resilience and efficiency required of a growing utility sector. With leak detection systems, heat networks can operate as reliable, sustainable, and future-proof energy systems, aligning with the broader objectives of net zero and long-term infrastructure planning. So, while the majority of legacy heat networks in the UK were installed with leak detection capabilities, a significant portion of these systems are no longer operational or fully functional. This has created a gap in the ability to monitor and manage leaks effectively. What are the issues with legacy systems? Firstly, there's a lack of understanding about the capabilities of these systems. Many operators and stakeholders are either unaware of how leak detection systems can benefit their networks or lack the expertise to utilize them effectively. Secondly, ownership and responsibility for managing the leak detection systems are often unclear. Without dedicated oversight, these systems can fall into disrepair. Another major issue is the obsolete or non-functional monitoring equipment in use. Older leak detection systems tools may no longer be supported, rendering them ineffective. Incomplete commissioning and missing as installed data also pose challenges. Without the proper documentation of the system's initial setup, troubleshooting and upgrades become far more difficult. Additionally, leak detection wiring often gets disconnected during repairs, rerouting, or redundancy modifications to the network, leaving critical sections of the system unmonitored. Finally, older leak detection systems generally lack modern remote monitoring capabilities, making them unsuitable for today's data-driven real-time monitoring needs. So how do we monitor heat networks with leak detection systems? There are two primary technologies used for monitoring heat networks: impulse technology, also known as the Nordic system, and resistance technology. Impulse technology is what is typically referred to as the Nordic system, operates by embedding two copper wires into the pipe insulation. These wires send low voltage electrical impulses along their length. When moisture enters the insulation, it changes the impedance of the wires, which the system detects and records. The approach not only identifies leaks and faults, but when paired with TDR, which is time domain reflectometry, it can pinpoint their precise location. Resistance technology, by contrast, measures the electrical resistance between two wires. If moisture is present, the resistance drops, indicating a potential leak. While this method is arguably simpler, it is less precise compared to impulse technology, as its primary signals the presence of moisture rather than locating the fault. Both technologies have their merits, but impulse technology is particularly well suited for the UK's heat network infrastructure, given its accuracy and adaptability to complex systems. Now that we've outlined the two types of leak detection technologies, let's dive deeper into how we identify and locate faults using the impulse technology or Nordic system and the TDR technology. How TDR works. Time domain reflectometry, or TDR, is the cornerstone of fault identification and location in the Nordic system. It works by sending electrical pulses along the embedded sensor wires in the pipeline. When the pulse encounters a change in impedance, such as that caused by moisture or damage, it reflects back to the monitoring device. By measuring the time taken for the reflection to return, we can then calculate the distance to the fault or leak. Monitoring solutions. There are two primary approaches to integrating TDR with monitoring solutions. The first is detection-only systems, which detect and alert the operators to a leak. These systems rely on the manual application of TDR technology after a leak is detected to pinpoint its location. While effective, this method introduces a delay in fault identification and resolution. The second approach includes fully integrated solutions. These systems not only provide real-time monitoring alerts, but also have TDR technology built in. This means they can both detect and locate faults in real time, significantly reducing response times and minimizing downtimes. With integrated solutions, operators can address issues almost immediately after detection. So Ratmon UK offers a complete range of hardware solutions categorized into monitoring or surveillance units, and then the tools for fault finding, testing and commissioning. Monitoring and surveillance units. Our monitoring and surveillance units are designed to provide a real-time insight and network-wide oversight. The RAT Combo and ILA utilize inbuilt TDR technology to detect and locate faults, and combine this with real-time monitoring with advanced data analysis, enabling proactive responses to potential issues. The RAT2 unit provides enhanced network monitoring with connectivity options for fault alerts. So for hands-on fault finding and commissioning, we offer a range of tools. The Megalock is a portable device, ideal for on-site fault detection and localization. The Smart Lock is a diagnostic device specifically engineered to support the installation and testing of pre-insulated pipe systems. And the Smart Box is a flexible diagnostic solution for fault simulations within the network, so supports fault finding, testing and commissioning of new installation or repaired pipelines. The accompanying software is just as important as it's linked to the devices and offers a comprehensive platform for monitoring and managing your heat network's leak detection system. Accessible via any web browser, it allows users to oversee their network from any internet-enabled device. The software automatically monitors the status of the leak detection system, analyzes it, identifies the fault, and determines their nature, be it a leak, a break, or a short. Its user-friendly interface provides clear visualizations of network status and precise fault locations. So beyond the hardware and software, Ratmon UK provides a suite of support services to ensure the optimal performance of your leak detection system. Our monitoring and surveillance packages offer cloud-based data access, complemented by automated analysis and reporting, keeping you informed about your network status. We also provide on-site support throughout the life cycle of your project, from planning and construction to ongoing operation and maintenance. Additionally, our training and consultancy service equip your team with the knowledge and skills necessary.
Are we done, Andrew?
Yeah, I was just going to do that last bit. So yeah, no, thank you.
No worries indeed. Brilliant. Thanks very much, Tom. If you don't mind putting the slides down, and if I could invite all the speakers from the first session to rejoin the stage, we'll just run through some of the questions. I'm thinking particularly Stephen Hart. I know Gareth Jones has left, Mark Woodward, Stephen Hayes, others have spoken. Brilliant. Hey, you're all popped up on the stage. Great. Okay. Steve Hart, would you mind just talking about your response that you gave to the question about I'm trying to go all the way back to it now. That was quite a long time ago, wasn't it?
Yeah, there was a particular question about what studies were done of the comparison between using the inbuilt trickle flow keep warm in an HRU versus the keep warm off with circulation at the top of the riser. Actually, Hanson-Graville did quite a lot of study on this. I remember a few years ago. He's speaking a little later, so I think he could be persuaded to share some of that output. But generally, it is a pass-fail criteria of the latest 2023 BESA test that an HRU in keep warm mode must have a standing loss, energy loss of less than 1 kilowatt hour per day, and if it doesn't, it fails. So an HRU trickle flow must be below that. The amount of flow needed at the top of a riser is a function of just the heat losses in that pipe work coming up from the heat source up to the top of the riser and back down again. Actually, the flow is very, very small. Some I know, Briggs and Forrester talk about less than 2% of the flow they detect, but it's down to what's the length of the pipe, what's the diameter of the pipe, what's the temperature inside on the water and outside in the climate, and also the insulation material and thickness. So really, it can be calculated or empirically measured on site using an energy meter. But specifically a report, I think Heatweb can help us out with that.
Sure. Okay, brilliant. Thanks very much. Stephen Hayes, there's been quite a number of questions in the chat which you've responded to on the Q&A. Are there any particular points you'd like to bring out that you've responded to? I was quite interested. Somebody asked about whether it was open source. Clearly, sadly, it's not, because somehow you've got to get paid.
Well, yeah, I'm a fan of open source. Don't get me wrong, Simon. But yeah,
no, absolutely. Maybe give me examples of. I was thinking of people that are using this software or have used this software. Are there other examples where you've sort of done fee-paying work that people could go and talk to them to get a feel for what they thought of it?
We, in truth, this is very early in terms of we're bringing this to the market. So what we're trying to do is lower that entry bar for the skill sets for people to do this kind of opportunity framing. So you can get yourself to a kind of feasibility REBA stage 2, typically done by the consultant in a very rapid pace now, in terms of finding where that opportunity exists and what that looks like. There was someone that asked around waste heat sources, and it's a brilliant opportunity, but from my experience, you have to be a bit more mindful about, it's all right putting everyone on a map, these are all the waste heat sources, and we want this to be a robust piece for to transition you into that delivery piece.
Yes.
And really, there's a lot of sensitivity around the processes that go on within these systems, these waste heat opportunities, and how you extract the waste heat from these different processes, whether that be the pottery industry, for example, or the steel industry. You know, they all have their own processes and sensitivities around the extraction of that energy.
Yes.
And so, you know, it could be, in my view, a little misleading to say these are all the opportunities, etc. You know, they're worth exploring, but it's not something to hinge that further development on until you have that dialogue. Once you've had that dialogue and you've been out, you can use the tools then to accelerate the piece after, when there's a little more certainty around that waste heat opportunity.
Yeah, no, indeed. Okay, no, that's brilliant. Thanks very much. One for Ket, and possibly I'll just cut you off. At your presentation, we run out of time. We've got a couple of minutes left. Higher temperature heat pumps. Could you just talk to us, or talk to the audience a bit about the sort of the COPs you're seeing for those higher temperature heat pumps in existing buildings? Because that's obviously a question that people commonly ask.
Yeah, the surprise is the difference really between air source, which we aim for 2.8, perhaps a maximum of 3. But when we compare it with water source, we're getting temperatures, we're getting COPs in excess of 4, possibly 5, when we're capturing waste heat. So if there is any opportunity to take heat from energy centers, from data centers, it's much better than starting with air source. One of the surprises is if we take water from a district heating network at 60 and deliver it to a building at 85, we're getting COPs in excess of 5.
Yeah, absolutely. Yeah, so it's very much about the input temperatures. No, it's very helpful.
Yeah.
And Mark and Andrew Sims, just to make sure that people understand, lots of existing networks around the country, lots of existing networks with alarm wires built into them. So are you planning to sort of overlay your offering on top of those existing systems? This is just purely for new build, is it, presumably?
No, absolutely not. I think the bigger problem we have, the starting problem, is existing networks. So we're very much about supporting those networks and bringing them up to speed, as it were.
Okay, cool, excellent. And in terms of that, detect and locate, that's a service that you offer people to do remotely. So presumably through some kind of SIM or something like that, you will actually do live monitoring of those networks.
Yeah, absolutely. All the units they're either internet or GSM enabled. So there's a lot of functionality around the units as to whether we can provide that monitoring service for the client, or the client can have direct access to that, whatever their preference is on the particular network.
Brilliant. Okay, brilliant. Well, no, thanks very much indeed. And a big thanks to all the speakers in the first session. I'm delighted that we've kept everybody to time. I think we've run through all the questions in the question and answer session. So thanks very much. I'd like to wish all the speakers a very happy Christmas, and I'll leave you to get a cup of tea and either wend your way or listen to the exciting talks in session 2. So thanks very much indeed to you all. Thanks very much.
Thanks, everyone.
Thank you very much.
Cheers.
Bye.
So we'll now move into session 2, and I'd like to invite Wim Jacobs from Zero Friction to come to the stage. So I can see Wim's joined us. Brilliant. Do you just want to say a few words, Wim, and I can check your mic's working?
Yes, can you hear me?
Yeah, speak a little bit louder. You're quite quiet.
Okay.
That's much better. Yeah, perfect. Right.
Is that better like this?
Perfect. So meter to cash operations, automation, customer experience and legislation. I will leave you to do your presentation.
Thank you, Simon. Hello, everybody. As you can hear, not a really native speaking English. I'm from Belgium, so I let you get used to my accent a little bit. But all nice to meet you. Okay, Zero Friction. We are focusing on really the billing and customer interaction side and we really want to make these things easy with the focus only on heating and cooling suppliers. I don't really like talking about challenges. I see it more as opportunities, but what we see not only in the UK, but I see that also on other European countries, we are active in many multiple countries, that the trust in the district heating is definitely, it needs to pick up. And therefore, I like to see that it's everywhere, is put a lot of focus. First of all, managing a district heating network. Of course, you have the technical side and the engineering side. But of course, as important is really your back office and front office, where you have to deal with invoicing, with your customer management, with dealing with move-ins, move-outs. If you look from the market challenges, okay, there are some historical perspective or historical challenges. Customer perception. We see that also with us in the Netherlands and in Belgium. There's some lack of trust sometimes, which impacts the further adoption. Of course, legislation changes are currently fully in progress. Definitely, you're in the middle of it, and in many other countries we are as well. But they require a lot of system flexibility, and there will be a lot of change coming. Last, which is really, I found even more important, is how can we standardize more? Because if we can standardize more altogether, we will tackle inefficiencies and errors due to more manual work or system gaps. So basically, how can we find this balance between trust, efficiency, sustainability, and regulatory compliance? We are really pushing the market towards with helping these challenges and the trends, and we are maximizing supporting this market. That's why we really see ourselves as an enabler of the market and helping the market with this challenges and with these trends. If you look at it, first of all, we look at how efficient can we run the billing, how can we help you scale, how can we help you supporting with the legislation compliancy, and of course security, because your data security is very important. And how can we help with creating more transparency and proactive communication? And of course, we need some other things to tackle is how can we reduce the cost to serve, and that we focus on having affordable systems from your first connection onwards. So meaning from day one, that you have full access to complete system support you in that. And last, how can we tackle complex IT implementations? That's why we have been thinking about it. But of course, that's one side. Secondly, is this legislation. Yeah, of course, I don't have to call you all in the middle of it. The heat trust, the Ofgem regulation, GDPR. So you need to have focus on more transparency and fairness. And ensure compliance is seamless and stress-free, of course, but also how can we build the trust and how can we be transparent to the end consumers about consumption, about pricing, about sustainability. So that's all kind of requirements in a very nutshell linked to your back office and front office or your billing domain. I would say from the regulation perspective, of course, much more details are provided in these. First, a quick note for myself. So I'm Wim Jacobs, I'm CEO and one of the 3 founders, together with this fantastic team that you see here with 43, in the meanwhile, friction fighters. We are working day in, day out on really setting the standard for the billing and customer interaction through a software as a service, which we are focusing on really making things easy and helping you with your running your efficient processes so that we can do that at the lowest cost to serve possible. And that's what this team is working on day in, day out. We do that currently in the Netherlands, Belgium, France, UK, and entering Switzerland, Spain, other markets in Europe, supporting these markets as well with creating these challenges. How we do that? It's a billing platform, like I said, and a customer interaction platform, completely white labeled, so that you can have it completely in your look and feel. So all the communication to your customers is happening within your look and feel through a cloud solution. And we make your IT landscape very easy. So if you look at the processes, but you have interactions with your metering data, both pay as you go, of course, and credit for the credit metering and credit billing. Of course, you're managing your contacts and your contact center and helping you also with your finance and your payments. So that's all the scope that we are supporting as of today. What can be seen as a few, I would say, key to success, and if you look at from a holistic approach, delivering high quality, efficient services, very important. Focus maximum on the automation so that you can improve your customer experience and, of course, keep your cost to serve low. Build trust through accurate metering. That's a beginning of all. As if you have a very proper metering data, the whole process will support you much better in your billing and your proactive communication. But it really starts with good metering data, and look at really how you can adopt scalable and also standardized systems. And of course, and we should embrace compliance because that helps us making things more uniform and helping make things more standardized. One example that we have done with the heat supplier in the Netherlands, Vaanster Energy, they have 14,000 connections in their portfolio at the moment, and they had a big challenge because they were dealing day in, day out with a very expensive billing process, and they had a lot of problems with the customer service. And also the managers, they were more in a firefighting modus than they were really in a proactive and modus and investing in their future growth of the company and future growth of the networks. So what did we do? We implemented together with them. We did a really detailed study also on their IT landscape, and we went to the implementation phase. We really saved a lot of time, mainly on the billing. We reduced the time. There was somebody with 1.5 FTE was full-time working month after month after month to get these invoices out to the customers, and we managed to reduce that to 1 week. So we reduced that with 75% of their time, which was quite impressive. And there was also linked to, of course, the metering data that was also not rightly set up, which we helped them with that as well. And then of course, it resulted also in a high improvement of the customer service. The number of tickets dropped enormously. We also managed to increase the operational efficiency and less hassle for the management team. The manager, that was the biggest compliment, the manager of the team, he was saying, I really can work on future growth and less on firefighting. So it removed a lot of stress. And we also reduced IT complexity and therefore also the costs related to that, because we managed to eliminate 3 from the 7 applications that they were using before, and of course replacing their billing system with ours. So that was a very nice success story, and that shows how we are supporting the market. And that's why we only focus on the heating and cooling market, because we can pick up a lot from the market, and we can really listen to the market and show that we can support them maximally. That's as you look from a heat supplier, but we also looking on how can we help bring trust to the end consumers. So what our end consumers are thinking about? Okay, first of all, heating, it's a basic comfort. I would say it's you want to have warm when you want to have warm. Of course, for not everybody, it's the affordability is an issue. But also, if you want, so most of the people, and you want to take a hot shower, you want to take a hot shower. So it's seen as a basic comfort, but of course that they want to pay for at an acceptable amount. But how can we maybe give also more control to the end consumers? How can we help them with controlling their consumption? How can we help them maybe with some proactive communication or gamification? And how can we, what are the kind of communications that we are expecting? Of course, there can always be something wrong. That means that you need to be able to be easy to contact in case of any questions. The customers are expecting really full transparency. That's the worst thing, is that either you can't find information or that you are wrongly informed. And what we see also, that helping them with the move in or move out process in a very digital and a smooth way helps already setting a bit of standard. and of course the reliability at all times, because delivering heat is all about delivering also reliability. So these are things where we are thinking of together with our customers and also with the end consumers on how we can support that support this process much better. So any input on this, always interesting to listen and how you see that. Final slide. I really would like to make a call. Let's set a new standard together. When we collaborate, we see that everybody can benefit. We see that in the UK, we are really, and UK, so in the Netherlands, we see that in Belgium and France, we are setting the standards, which is really helping, building trust, because reliable, efficient, cost-effective process to power your successful heat network. We are making sure that you always stay ahead. That you are in line with the regulatory compliance, and who help you then unburden you, I would say it, with this process. And also a warm call to everybody. Let's see how we can build trust and drive sustainable growth in the heating sector together. So with this call, I want to thank you, and I'm happy to answer some questions later. Thank you.
Brilliant. Thanks very much indeed, Wim. Much appreciated. And I'll ask you to come back later for some Q&A. So Casey Cole, who's replacing Sula, cannot be with us this morning. If I can invite you to join the stage, Casey. So thanks very much indeed. So I'll hand you over to Casey from Guru Systems, who'll be talking about the importance of data for the upcoming regulations. So over to you, Casey.
Fantastic. Thanks, Simon. Can you hear me okay?
Yeah, I hear you perfectly.
Sweet. Okay, cool. So as Simon mentioned, I'm not Sula. I'm Casey. Sorry about that. Not least because Sula is always great to listen to, and also because I think she was the only woman speaker on the program. So I appreciate UKDEA doesn't control who members put forward to speak, but my plea to other members would be to put forward folks who better reflect the diversity in our industry. I think everybody's keen to see that happen, including me. So anyway, I will do my best to fill in for Sula in this one. As Simon said, I'm going to talk about the importance of data for the HNTAS regulations in particular. For those of you who don't know who Guru is, we provide hardware and software as a service to heating and cooling networks, and those systems are used to pull out large amounts of energy performance data from those systems, and also to exercise control in the other direction, as I'll tell you briefly about. It's for two main purposes on behalf of the operator. One of them is metering and billing. That's the slot we're in today in the conference. And the other one is for energy performance. And it's that one that I'm going to home in on in the context of HNTAS. So let's talk about that data. We've only got 10 minutes, so I'm going to hustle through this. But let's talk about what data is actually involved in the HNTAS regulations and what we need to do with it. So this is a little bit busy, but bear with me. I want to talk about where the data comes from, the path that it follows from when it's generated at the point of measurement all the way through to where it's consumed. So if we start on the left-hand side in the blue box on the far left of this diagram, this is where our data is coming from. We're collecting this data in order to calculate the KPIs. So keep in mind that, as Gareth was talking about earlier, we've got different phases for HNTAS and we've got different elements. But we need for each of those elements, and he talked about 6 of them, for everything other than the heating system inside the consumer connection, there are required things that we have to measure and calculate. Not enough just to measure them, but we have to take that data and carry out calculations to show whether minimum standards are being achieved, right? So that's the aim here. We need to collect the data that's required for those KPI calculations so that the output can then be handed off to the regulator to assess whether or not we're compliant as a heat network. So the far left-hand side here in blue, that's where the data, the kinds of data get collected that we're going to need later. And we can see up at the top of that blue area is heat meters. It could be cooling meters on a cooling network. But these are the kinds of meters that everybody's familiar with. You find them at consumer connections, so in dwellings, but you also find them at block level, at energy center, sometimes at substations. They are the data source that we usually think about when we think about monitoring a heat network. But for Huntas, we actually need a lot more than that. We're also going to need data from the licensed utility meters. We might need to know for a legacy network how much gas is being used so that an efficiency balance can be calculated across a set of boilers or CHP. We might need to know the amount of electricity that's being consumed in a large heat pump. Beyond the licensed utility meters, we also need things like sub-metering, right? So if we need to measure how much top-up water is going into a heat network, we're going to need a flow meter. We're going to need that probably in the plant room or at the substation. We might need to sub-meter in some circumstances in order to gather the data needed for KPIs. For example, pumps. Take ambient loop networks, for example. Pumps are a massive source of energy consumption on ambient loops because the flow rates are high. So in a situation like that, it is likely that it'll be required to calculate, or rather to measure, how much electricity is being used by pumps on heat networks. And then there are other sources of data that aren't meters at all, like differential pressure sensors to calculate differential pressure uptime, or water quality data. Okay, so we have this massive range of endpoints that we're going to need to access in order to pull data out that we're going to use to calculate KPIs. And the heat metering, particularly the heat metering at the dwelling, it's just one part of the story. Once that data has been collected, then it needs to get out of the site. And that's via something that's often referred to as backhaul or data acquisition. That's the sort of teal bit just to the right of the blue section. And you can see that that's often done via automatic meter reading, which could be using different technologies. Also, you may be getting that data not from site, but directly from a licensed utility, for example. You might be hitting their API, you might be hitting their servers in order to pull down that data over the internet, rather than taking it directly from an on-site meter. In the case of submeters, it's probably automatic meter reading or AMR. And in the case of some other metrics, we may have to pull them directly from the BMS or from other sensors on site. And that requires a kind of adaptability and interoperability with different systems in order to pull all that data together and get it off site into the sort of yellowy section in the middle, which is the data center. You need to get it into the data center to ingest it. You need to store it. And then that measured data is going to get used to calculate those KPIs. That's that little loop up to KPI calculation engine. You need to store the results of those KPI calculations. And then you're going to need to hand that data off to the people who need it. Now, that data needs to be used by different stakeholders. One of those stakeholders might be the heat network operator themselves, in order to monitor that it's working properly, identify where problems are, go and fix them when things go wrong. Another stakeholder is the regulator themselves, right? So those KPIs are going to have to be handed off to Huntas under Ofgem to demonstrate compliance. And another one might be the metering and billing company, who needs a subset of that data in order to bill customers. It's a very rich data set. Different stakeholders have different requirements, and it's important to differentiate between those end users. You have to do that in a way where only the right people are seeing the right data, often referred to as access control. Okay, so we have to either push or pull that data into the right places via an access control layer. So these are all the ingredients in the system called an ARMS, just another acronym in case we needed another one, the Automatic Remote Monitoring System, to take this data from one end all the way through to KPI calculation and then on to the stakeholders who need that data. This is the picture under regulation of what will need to be in place. Where does Guru fit in? Well, we provide hardware that does the AMR job and interacts with kit on site. Doesn't have to be our kit, can be other people's kit. And we also provide the data center services and the applications for visualization and data handoff. I've only got a couple of minutes because we are trying to do this in a hurry. So I'm not going to talk more about how we fit into the site, but I want to just contrast. I think there's some confusion about the connection between metering and billing, again, the slot that we're in today, and the data requirements under HNTAS, and what data is actually required. So if we take a look at traditional metering and billing and the sort of thinking around the data, what meters are required? Well, M&B usually thinks about the meters you need to charge people. Makes total sense. You got a customer, you need to measure their consumption in order to charge them for what they use. But HNTAS needs all the meters, and not just meters, as we have seen. We need the heat meters at the consumer connection, we need the bulks at the block level, at substations, and in energy centers. The frequency of that data in traditional metering and billing could be daily. Maybe it's hourly or half hourly. The proposal under HNTAS regulation is half hourly at the consumer connection and then 5-minutely at bulk meter levels. Traditional M&B needs that kilowatt hour count. That is the crucial number in order to generate a bill and charge people for it. But under HNTAS, we need all the things that heat meter knows. We need flow rate, flow and return temps, instantaneous load, cumulative volume, etc., and kilowatt hours. But we need all 6 things, not just one. And that data in traditional M&B is gained from heat meters. In HNTAS, as we've seen, it's actually a whole range of devices. We've got heat meters, yep, at the end of the network and at intermediate spots. We've also got licensed utility meters, check meters of different utility types, including top-up meters and electricity submeters, and then sensors like differential pressure and water quality. In fact, water quality data might even come from a lab in some circumstances. So it's a really wide range of sources that we're going to be drawing from in order to do our HNTAS calculations. Last slide. What's our approach to this? So our approach is one of data transparency. We need to also focus on interoperability, not just with our kit and others, but also on site, reading other people's kit, or in some cases, sending control messages back down. We have to make sure that all these different systems are tying together in order to put data for all stakeholders into their hands, the right data for the right stakeholders. And then we have to glue that all together in order to ensure that the heat network operator is able to comply with their HNTAS requirements. And that is Sula's presentation.
Indeed, Casey, much appreciated. Thanks very much. We'll hopefully be taking questions later. Can I just ask Richard Hanson-Graville to come online now from Heatweb? He's the technical director and he'll be talking about energy efficiency monitoring. So brilliant. Thanks very much indeed. Let me just, cool, excellent stuff. And can I just ask all delegates, we've still got lots and lots of you at this event, tens and tens, could you please put your questions in the Q&A, because that's the place we'll be calling questions from at the end of this session. We've got Richard to speak, we've got Anthony Coates-Smith to speak, then we'll be doing another Q&A. So any questions for Wim, Casey, Richard or Anthony, could I please ask you to put them in the Q&A session, please? Without further ado, Richard, do you want to say something and I can check your mic's working?
Good afternoon, everybody.
Perfectly, working.
Magic. Hello, everyone. Right, I'm Richard Hanson-Graville from Heatweb Solutions. I'm here to talk you through some technologies that we've been working on to assist in much of what you've been hearing about today. So why do we need quality assurance on heat networks? We run a number of H&S jobs over the years, and the sort of stuff that you find when you're out of site is we all know what goes on out there. So the whole idea of a lot of what's been talked about today is to gain quality control on the industry. To put this is just to put timescales into perspective. We've got about 10 years, roughly speaking, till we blow through the carbon budgets. And the point is, what's visible, what gets measured, makes things visible and action gets taken, is the general gist. So what we're talking about here is a system that complements the existing HNTAS proposals by providing visibility, quick turnaround visibility on existing networks through the BMS systems. Oops, sorry. So what do we know that works out there in the industry when it comes to achieving quality? A single KPI when on display motivates all stakeholders to improve quality themselves. So this goes above guidance standards and all the back-end technical into what's on public display, what drives people to pull their socks up. So as already touched on, the BESA HRU test regime is probably one of the most successful projects that we've all seen. This is an HRU that when we were manufacturers that we were part of the design of, which the VART figure, so the volume weight average return temperature, was the key metric that has driven the sort of quality on HRUs by putting it on public display, so competitors are competing against each other around a single metric. And everyone's seen how that actually drove within a year. You know, all the manufacturers were pulling their socks up. And the same principle can apply to heat networks. So one of the things that everyone's developing in HNTAS is a set of KPIs for confirming the operational performance of systems and to alarm them, to make sure during acceptance testing that everything is ticking all the boxes. This slide just shows you an idea of sort of things like VART temperatures, return temperatures, data points, reporting from systems. So this is some of the KPIs that's been proposed within HNTAS, as well as a few others people may recognize, with this sort of traffic light status here. So what we're really talking about in general here is BMS focused quality control. So we're talking about making use of the existing BMS systems and the head-end systems that already have eyes on pretty much every single data point that's concerned in a heat network, including all the bulk meter data, substation controls. A lot of the residential meter data is now coming through these systems. So it's the central focus where you already have appointed expert engineers on site that are capable of setting up these back-end data systems for compliance. So what we're really focused on is how can you best make use of these existing systems to achieve compliance. We've touched on the infrastructure already, but this is a similar style of infrastructure, but it's built on the existing IoT standard protocol. So MQTT, for example, is already up and running pretty much in every BMS system. It just needs turning on. Almost all IoT systems use MQTT. It's the default protocol. And an MQTT envelope effectively allows, it's the default way at the moment of communicating data points between, say, different BMS points, control systems. So we effectively extended that to cover, well, it already covers everything in, say, the energy centers, substations. So that's the back-end infrastructure that's already in place that just requires turning on in existing panels. The additional infrastructure, which has already been touched on again, is the cloud storage end, which is the process of ingesting data into a database system that holds your KPIs, your historic time series data, your KPI functions, and point definitions. So it's a standard structure basically built on open source technology. These back-end systems allow you to perform, queries, standardized queries, so that you can present your data pretty much through any front end system that has access to a standard, say, Postgre database through a single function. So this is a volume weighted average temperature for my site. I want the side wide heat meter. I want the return temperature weighed by the volume flow. And then these are presented in KPIs. So I'm going to shoot through a bunch of KPIs. These are the kind of KPIs that we've got on live sites, which come alive when you turn these on in the BMS. Some nice things such as substation efficiency, and also we're putting in bulk meter data points alongside BMS data points. So these should all be the same color. And often your meter data we find is inaccurate, and your BMS data is inaccurate. And when you lay them together, you see some leap out, and that can direct works. And you find a sensor, about a BMS sensor or a meter sensor, like lying on the floor or something such as that. There's KPIs for bypass flow energy. So these are all available from the BMS systems once you turn them on and run them through, like say, a KPI function. A gas boiler or conversion efficiencies. Surprising how that can vary by the boiler. Heat pump KPIs. This is an R&D project we were doing. I think it's the world's first CO2 heat pump heat network that was turned on 2 years ago, which is achieving some remarkable Vate temperatures or temperature difference on this network. But it was the visibility basically through the BMS that controls it all that enabled this to sort of get to where it was. Buffer store KPIs, loading, discharging of buffer stores. That needs to be, you need eyes on that sort of stuff. Central heating KPIs. So this is operation of 19 zones of heating. The point being, it was manifold control. The point being to achieve accurate room temperature and low return temperatures. Again, KPIs on return temperatures, the same site. I think on this site we're now down to Vate temperatures of around 19 degrees C. So it's a very performance system driven really by having visibility on KPIs. Water quality KPIs. So the detail of these, because it's open source, it allows various experts to focus on KPIs that they require for their systems. So this, for example, is a Heath Shore water quality system run through KPI system. HIU data, we've got a lot of residential meter data. Through certain things like volume flow, you can identify faulty, inefficient, healthy and isolated systems, plot them in various ways, present them in alarms. Right, you've got energy efficiency, benchmarking systems. This can be done through the BMS data. And this is an idea of pulling it all together. So you've got standardized KPIs that you need to know whether you're conforming to. You've got historic of those, because sometimes KPIs, they fall out during the middle of the night and you don't see that. So you want a nice system that's visible, and is plumber proof effectively, can run on mobile phones, and can help direct works. We use open source software such as Grafana as the front end, because it's got very well established, it's cross industry, it's got all the operational alert system back end, user organizations, so you can create different access rights based on different users. And again, nice thing about cross industry is got Grafana dashboards which you're running the energy systems on one side and you're running an industrial process on another bit. Open source does get people a bit worried. There's a distinction between well-established open source technology, such as the ones we're using, which, for example, Postgre database runs the back end and does all the KPI functions. And who uses that? I mean, it's the back end system for most major corporations in the world. They'll all use these front end systems for visibility, and MQTT is the default IoT protocol that already exists in all BMS PAN systems. So we're basically turning on technologies that are already there. What can we do with this? Now, this is a comparison really of human oversight versus BMS oversight. So they complement each other. We see the BMS side of things as a short scale. You can turn it on within 24 hours through an existing system, overlay a dashboard, and it's a quick fix to get eyes on a lot of stuff. It's different from all that doesn't apply to the design stages. And you do obviously need a certain level of acceptance testing. The short things really, BMS it's a computer saying yes and no. There's very little human error, very quick to set up. It can be shared by all parties, run on top of all manufacturer systems. There's no competition going on there. And it's already in use. So it's a system that's already in place on 30 plus networks, and it's just expanding now to cover HNTAS KPIs.
Cool.
Okay, thank you very much for listening.
Brilliant. Thanks, Richard. Much appreciated. That's good. Can I ask Anthony Coates-Smith to come online from Insite Energy? Anthony will be talking about the importance of metering data for heat network improvements. So just before Anthony starts, again, could I just really put a big shout out there? We've got a heck of a lot of people still online on this event, but we're getting no questions, which is staggering me. So if I could please ask for questions to be raised in the Q&A session, that'd be super. Otherwise, I'm afraid the chairman will take his prerogative and ask some questions anyway. And just to preempt the speakers in this last session, I will be asking all four of you, in absence of any questions, what the single biggest issue you think that you need to be resolving over the next 5 years in heat networks in your space, in this whole metering billing data space. But anyway, in absence of that, Anthony, do you want to start talking? I'll check your mic's working okay.
Sure, thank you, Simon. Can you hear me?
Perfect, lovely. Thanks, Anthony.
Brilliant, thank you. Good morning, everyone. I'm Anthony Coates-Smith, Managing Director of Insite Energy. For anyone who hasn't met Insite before, for the past 14 years, we've been providing services to over 300 heat networks in the UK, all of which are not-for-profit heat networks operated by private or social landlords, serving over 35,000 homes and some commercial connections through the UK. Our services comprise provision and operation of metering and pay-as-you-go systems, metering and billing services for each residence, and full operation and maintenance of heat-related assets on site. Now, I'm here today to talk to you about the importance of metering data for heat network efficiency and improvements. So why does metering data matter? Well, accurate meter data is a critical factor in ensuring the successful operation of heat networks. So all stakeholders in a heat network rely on meter data to ensure compliant and efficient operation. Effective monitoring of meter data will quickly identify when and where things may go wrong, enabling faster remedies and better outcomes for protecting consumers and operators alike. Upcoming regulation positions meter data and periodical reporting of that data central to the first tranche of regulation rollout, and it's expected that requirements for and use of data within regulation will grow and become more prescriptive over time. But remember, efficient operation of a heat network isn't just minimising heat losses and the physical supply of heat. We must also consider efficient administration too, to accurate billing and the financial management of the heat network, a lot of which is based on the availability of accurate meter data. Sorry, Simon, is the next slide moved on? I'm on to the second slide, sorry. And third. Thank you. Knowing the importance of meter data to the effective operation of a heat network, we want to ensure that we ingest as much meter data as possible to give us as full a picture of the heat network and enable a high level of service to consumers. Thinking about your network of meters, if you operate a heat network, you need to monitor them and ensure they're actually working and reporting. So your meter health, therefore, is a high-level dashboard indicating what level of meter data you're receiving. Actively reviewing this KPI should provide you with the triggers to instruct meter repairs or investigations to keep meters working and reporting. Aiming for a meter health target of 95% is a good start, as is considering a meter repairs response time of less than 1 month, so within a typical billing cycle. But I'd actually recommend a repairs response time of less than 1 week if you can. Meter health is of course an indicative KPI, and whilst it's a great one to have and to use, we have to remember that there will be exceptions such as void properties, which might trigger a meter alert that you need to filter out effectively in order to avoid wasted cost in call-outs or follow-ups. Ofgem and HINTAS will stipulate the minimum standards and frequencies as we move into the regulated world. However, good operating practice in all aspects of running a heat network, not just in regards of efficiency monitoring and improvements, requires a complete picture of meter data as your start point. Therefore, ensuring meter health is maintained on an ongoing basis is a key operating requirement. Sorry, I have a mouse issue. If you guys could move on, there we go. So it is hard to convey in a 10-minute presentation the many ways in which metadata can be used and interpreted to deliver operational improvements for heat networks. So I'll mention instead 3 high-level interconnected focus areas, all of which we could do a deep dive into if we had the time, and which we'd be happy to do offline for anyone that's interested outside of this session. First of all, heat network operating efficiency. It's come under the spotlight more since the energy crisis drove the price of gas to new heights. Metadata is the source data from which heat network operating efficiency can be calculated, which is why upcoming regulation is so focused on ensuring the right metering and data granularity is in place. Effective reporting mechanisms will follow that require operators to engage with and share data with Ofgem, and either to demonstrate good operating practice or to evidence a roadmap for improvements in their operation. Second area is financial operating efficiency. This is critical to the ongoing viability of a heat network, none more so than with those operating on a not-for-profit basis. Aside from using metadata to monitor the performance of a heat network and direct either reactive or planned maintenance interventions which fix faults and improve overall performance, metadata is also used to calculate accurate tariffs. These underpin the financial performance of our heat networks. If metadata is used in conjunction with financial reporting on heat networks, the data will aid identification of changes in performance that, if left unchecked, may be of significant detriment to the financial health of the heat network, with potentially dire consequences for both consumers and for operators. And last but not least, the consumer experience of a heat network is heavily influenced by how effectively the network is administered and managed. Accurate and consistent metadata benefits consumers not just through the contribution to operating and financial efficiency, but also through a first-time right approach that ensures tariffs are based on actual metadata, thus are more accurate, and that customer bills are based on actual meter readings and consumption, so are less disputable, giving rise to less complaints. Consumer trust is hard to win. The use of accurate metadata in billing is an absolute tenet in underpinning the heat network operator good practice and in building consumer confidence. In summary then, without metering data, we simply cannot accurately and fully determine how heat networks are performing to the lowest common denominator, which may be the in-property heat supply. Heat networks comprise a series of interconnected assets and components which, if operating in harmony and designed to do so, will be efficient, cost-effective and reliable. Consumers and operators will likely feel the impact of a poorly operating heat network, and many of us here, sadly, will have experienced poor-performing heat networks in practice. Issues may include heat outages, leaks, overheating throughout buildings, poor financial health with cost implications for consumers and operators alike, inaccurate billing, and generally a lack of transparency of what is underpinning those issues, all of which is detrimental to customer and operator experience and damaging to the reputation and acceptance of heat networks in the UK. But monitoring of metadata and the effective interpretation of it enables heat network operators and their suppliers to actually see how the network is performing in each of those constituent parts. Operators, however, must have competent processes and people in place, whether internally or through outsourcing specialist service providers, to take metering data and turn it into business intelligence for decision making, with the intention of improving or maintaining performance of heat networks for all stakeholders. Thanks for listening, and please do reach out with any questions. And Simon, I've won you some time back there.
Brilliant. Thanks very much indeed. Much appreciated, Anthony. So, Tom, if we can pull the slides down, if I can ask Wim, Casey and Richard to rejoin the stage, that would be super. Thanks very much indeed. Okay, great. Thank you very much. I think we've stunned the audience, which is still well over 100 people or more, into silence, so no questions. So I will revert back to Chairman's prerogative and go around each of you and ask you what the single biggest challenge you think facing the sector in your particular space is. So shall we start with Wim, as you went first, and then we'll go in order of the speakers. So Wim, what do you think the single biggest challenge that we're facing in this sort of space is?
I would see two things, and they are linked to each other, I think, is the speed of rolling out the networks all over Europe, not only in the UK, but everywhere we have the same challenge. But linked to that is how can we keep that affordable, and of course how can we keep the trust high. And all these things are really hanging together. I found and that's a key challenge that we are still facing at the moment.
Brilliant. Okay, cool. Thanks very much indeed. Casey, what do you think is the single biggest challenge we're facing at the moment?
For us in the UK, it has to do with regs and this change that's about to happen in about 12 months, where we're moving to an approach where you have to measure outcomes, both during project delivery and then in operation, and that there's a minimum level of goodness. So that's the backdrop. I think the biggest challenge that comes with that is the interoperability and the security of the systems that are out there and are being installed. As I was saying in my bit, but also I think that Steve from Baxi was hinting at, as Richard Hanson-Graville was talking about, and I think Wim was talking about, you've got to get different systems working together effectively in order to get this whole end-to-end picture working for collecting the data, doing the calcs, handing it off to the stakeholders. Interoperability is not something that we've been great at as an industry over the last sort of 15 years, but we're going to have to hustle because the regs force us to do it.
Yeah, cool. No, thanks very much indeed. Richard, what do you see as the single biggest challenge?
Well, I agree with Wim and Casey, but really on top of that, it would be the politics of turning the lights on. There's a lot of legacy stuff out there, and there's a lot of politics to get through, getting things up to quality. A lot of people don't want to be embarrassed, or they want, there's a journey to take a lot of people on from a lot of different angles to the point where everything's transparent and working. That we're finding is probably the biggest challenge when you've got so many players, certainly on big city networks. Yeah.
No, great. Thanks very much. And Anthony?
Well, no surprise, regulation is going to be the biggest challenge. I think in particular, the thing that is most concerning at the moment is how Ofgem intend to regulate customer protection. So I don't think anyone would argue against greater customer protection, but in particular, there are some concerns I think a lot of people in our sector would feel around the treatment of vulnerable customers and self-identifying as vulnerable without any checks and balances, and the affordability impact that might have on not-for-profit heat networks or potentially smaller heat networks funded by a council or a housing association. So I think the current view looks very frightening if we're going to see people not having to pay anything towards their heating for a 6-month period based on what they say their status is. I don't know what financial safety net is going to be in place for those operators and how they keep paying the gas bills or electricity bills during that time. So it's not a done deal. Ofgem obviously going to be taking feedback through consultation. Hopefully they'll listen and come up with a solution that works for everyone.
Yeah, no, absolutely. No, indeed. I think that's a really good point. I mean, the UKDEA's got an Ofgem webinar on the 16th of December. For those who've been attending the Ofgem webinars to date, I sense there's a bit of Ofgem webinar fatigue in the sector because there's been so many of them. There's also a bit of Ofgem webinar frustration because they don't respond to the Q&As in writing, they don't record the events, they don't circulate them afterwards. It's quite an opaque thing to do. So just for any UKDEA members or anybody who wants to rapidly join the UKDEA to get in time for the 16th, we're having a one where we're actually holding them to account. Ofgem, we will be recording the event. We will also be making them give us written answers to the questions as well. So it'd be much more of a, rather than Ofgem just talking to us and we sort of sit there trying to understand what they're saying, it'd be very much us asking the questions. There's a question from Hen, which I think we've kind of covered. It's about proprietary systems interoperability is a big issue, unless any speakers would like to cover that. But I think Joel Debson's asked a fresh question. How are private networks going to manage tenants or their leaseholders as they have no direct relationship or have been involved in the past with this end of the process? If that question makes sense, I've tried to interpret the question. Any speakers who'd like to respond to that, feel free.
I think, Simon, I'm not sure it exactly answers the question, but the difference between a leaseholder and a tenant in the eyes of Ofgem, I don't think has been properly clarified yet. So who is the consumer? A heat network operator has a contractual relationship with the leaseholder, which requires them, in most cases, to pay for the use of utilities back to the landlord. But do they swerve that responsibility if a customer is now the end user under the eyes of Ofgem? I don't think we've got the answer to that yet. It's one of the things that needs clarification.
I chip in. I think there's an angle on it, which is, like I say, in parallel with the regulation side of it, you also got the pride side of it by putting a metrics on public display, so that can drive quality control without maybe getting so many legal trip ups on the way.
Yeah, cool. No, absolutely. Would any of the speakers just like to give a 2-second explanation on VWatt or VWatt? Anybody want to put their hand up?
Yeah.
Oh, go on then. I'll
go on.
It's
a layman's response, please, Richard.
It's the average temperature, but you don't count temperatures when there's no flow rate. So you're weighing a temperature by how much water is actually flowing. So you're weighing the average temperature of the volume of water rather than the temperature of a pipe over time, which is pretty meaningless for most applications.
Excellent. And before we all let you go, would any of you like to talk about this interoperability question that Helen's raised and proprietary metering systems? Anybody would like to jump in on that one?
I'm happy to.
Go for it, Casey.
Okay, so yeah, interoperability is going to be fundamentally important when we're talking about the data sources on the left-hand side of that diagram I put up. In some cases, you are going to be interacting with old systems, closed systems, things that are hard to interact with, and we're just going to have to get on with it. That includes talking to things like licensed utility company servers via something called an API, which is just a defined set of rules for servers talking to each other. So we're going to have to deal with an entire range of the kinds of things that Richard was talking about. So fully open source systems that may still have encryption and key management. So there's still rules for making sure that the right people are accessing the right data, all the way through to things that are quite closed and proprietary. But we have to work with what we find on these sites. Right, so we're going to have to make the best of what's already been put on a whole bunch of legacy heat networks. Yeah. And there's whatever rules we decide to put in place today, we've got close to 1 million domestic connections on existing heat networks that we're going to have to grapple with and do the best that we can interoperability-wise.
Okay, that's a very interesting number you've just mentioned, Casey, because I've only ever heard 500,000. So there's another 500,000 more people on heat networks than I was aware of 5 minutes ago.
I'm happy to show my working, but yeah, it's something like between 950 and 1 million, I think.
Okay, very interesting, very interesting. Well, on that very interesting point, I suggest we draw it to a close because we've run out of time. I'd like to thank all the speakers and wish you all a very happy Christmas. And if you'd like to stay around for the third session, just to listen in the background, please do. But otherwise, thank you very much indeed. Thanks very much.
Thank you. You too. Bye.
Okay, so we'll now launch the third session, which is very much moving into the operation refurbishment stage. And I'd like to invite Gabriel Gallagher, who's the Managing Director of Sustainable Energy, to come on. Gabriel will be talking about the Dufferin District Heat Network. They're members of the UKDEA, as is Gabriel with Sustainable Energy. And Gabriel has been working with our member to look at the refurbishment and optimization of that network. So do you just want to say something, Gabriel? Check the mic's working.
Yep, good morning, just about morning. Yep.
Perfect, excellent. All over to you. Thank you.
Thank you, Simon. Well, yeah, I've been introduced, so I'm going to spend my 10 minutes or so talking through the journey that we've been going through with Newport City Homes, taking them through optimizing, decarbonising the district heat network, which has started some sort of 10 years ago, and over this time delivered several projects for them to reduce costs, increase efficiency, and decarbonise the heat that goes to their customers on the network. So I'm going to move on. The system, the Dufferin District Heat Network, was first installed about 1978. I think it was operational installed by Newport Council at the time. And the scheme supplied heat and hot water to terraced houses, flats, totaling some sort of 970 dwellings, as well as supplies to local school and care home. Energy centre for the scheme was primarily fired by gas, but had oil boilers in there as well for people in reserve. And there's about 3.5 kilometres of network, steel network installed by Moller Pipe back then, and most dwellings received heat then around sort of 82, 71 kind of conditions for heat and hot water with vented hot water cylinders and radiators. Heat networks now run by Newport City Homes, as Simon was just saying there, and our work over the years started with sort of initial feasibility decarbonisation planning, moved pretty quickly into developing designs and work for a centralised biomass energy centre. Followed through with construction management for the whole new energy centre, operational 2016-ish. Project followed by refurbishment of radiators, heat interface units, run over a couple of years, 1,000 properties, going through them steadily. Once that was complete, sort of specification for the existing energy centre, the old gas-fired energy centre, to upgrade pumps and controls to manage flows and temperatures, and then an exercise in sort of 23 around options for replacing the existing network as it came to its end of life, and run a project there which led on to the installation of a new network and ongoing with data systems monitoring and optimizing that network. So first project was the Biomass Energy Centre. So this was built on top of where the old oil boiler storage area was for the energy centre. It's about 2.5 megawatts of biomass boiler with electrostatic flue gas cleaning, so very low particulate emissions from there. A large thermal store and nice tall flue. All the part of the contract was to procure local wood chip, and there was a large bunker system in the design to receive sort of up to 1 Arctic lorry per day from about 20 odd miles away, local sustainable wood fuel. The site was still backed up, the existing gas boilers, only the oil was removed from the site. And the project then, once that was in construction, the next stage was to look at a full heating refurbishment across all of the dwellings. So let's see, the process there was just reviewing all of the dwellings. There were sort of 3-bed homes down to sort of single bedroom flats right across the whole site. Principles to drop temperatures based on the sizes of the properties and the constraints at the time, was moved to a sort of 70-40 design on radiated heat, removed all of the open vented hot water systems, and installed direct heat interface units. So the process then, just run over a few years to move through the properties, keeping all the existing properties on the network operating, whilst going through block by block, refurbishing different dwellings as it goes. The scheme or the project also involved new heating metering bidding, and then the sort of the acceptance of that, because the conditions of the network were different. So we're probably dropping temperatures in those radiators, getting residents used to the fact that their radiators were going to be cooler, but yet they were still going to be kept as warm, and that their hot water wouldn't run out from their previous systems. So part of the process there was commissioning, witnessing, accepting each and every dwelling, and recording that. Once that was complete, the next project was pump upgrade and controls. So obviously the existing as we're moving through the replacement over time, all the flow rates and temperatures were sort of left as they were to manage that that changeover. But I wouldn't say all, because there are some private some leaseholders within those 970 dwellings, so not everybody opted for a new system, or there's some that maybe didn't open their doors or let anybody come in to install it. So there were a few left over once all the ones we could achieve were done, which nearly all of them, high 90%. Then there was some monitoring of that network operation, and a move then to drop temperatures, generation temperatures down to around 75 degrees, and with the increased LT of the whole network, that allowed removing or changing out of the sort of 3 existing sort of 50 kilowatt pumps with smaller summer pumps and operational pumps, which opened up or produced large electricity savings, sort of tens of thousands per annum in terms of just electricity savings alone, and implemented some basic pump speed control at that stage of the scheme. Then, as that network was some sort of 46 years old at that point, and see one of the images there, the Newport City homes have to keep various devices to address leaks if they came up on the network. So to try and get ahead of the new network opportunity, we ran a sort of design options assessment, looking at different network materials, different network approaches, and explored the opportunities to reduce diameters down for an ultimate replacement of the heat network. Carried out some sort of energy savings, cost benefit analysis, produced a design and spec for a new network that could replace the existing network. In the preceding year, then the HNES funding opportunity opened up, and we helped Newport City Homes then apply and be successful for some 3.7 million of funding towards a new network. Worked through the planning applications and procurement to get the principal contractor on, the main contractor for the installation. So there was sort of about 3.5 kilometers of new network then at much smaller pipe sizes than the original one. I think 2 line sizes down in many cases, connected 31 substations to the main energy centre, which was all of dwellings, school and care home. It was a hybrid in the end, hybrid of steel and polymer network. We had to keep the old system live, keep all heat on to all residents and customers during the installation. Didn't need to keep their local environment intact necessarily, but had to keep the heat on. And new ducts were also installed at the same time to allow a future heat network, data network for all meters and sensors. So that was put in at the same time. So that project finished up in this year, so early 2024. So since then, we're ongoing, getting all the index pressure sensors back to the network, reducing temperatures again. Now we're sort of losing less through the network. We managed to squeeze some more degrees down on the leaving temperature from the energy centre, and have managed to reduce flow rates again with the higher efficiency of network, and are in the process of driving more savings. There are some blocks that are performing better than others, so now the data's coming through, we can start targeting and getting all the blocks, all the main substations into good operation. So as the to explain or to show the results of that decarbonisation journey, the timeline, our base map in 2014, or baseline in 2014 was, it was firing on gas, and once in a while a little bit of oil. There's quite high electricity consumption at the time, higher flow rates and higher pumping. But once the Barnard Energy Centre was installed and operating, so made significant impact on carbon reduction. So that was the big drop in carbon intensity. So the black line there is the overall carbon emissions from Dufferin as a whole estate, and then the bars over the different years are how that energy reduced and changed in terms of where it came from. 2018 and well, actually sort of a bit longer than 2018, but starting in 2018, all the HOUs and radiators, that all brought with it energy reduction. The pump operation made further savings. The new heat network has brought greater savings in terms of heat losses through network, much smaller diameters, larger insulation levels, and in some cases some shorter network routes. And an optimization will carry on. So over that period, we've almost halved the energy inputs to the whole network. These aren't degree balanced networks. I can't tell you whether 2014 was a considerably warmer or colder year than 2024, which are the real data points. This is all half-hourly monitored fuel consumption through this period. So that's the decarbonisation journey for Dufferin, and work continues to keep that going. So nearly 50 years of operation, and another 50 plus to go. And I thought I'd just add a slide at the end just to sort of make sure that named the sort of organisations that were the different contractors through those different projects as they were delivered. Make sure everybody gets their mention and recognition for the work that's gone into that whole journey. And that's me. I think that was 10 minutes. So thank you very much.
Brilliant. Thanks very much indeed, Gabriel. I'll invite you back for Q&A at the end, but there are some questions in the Q&A session already if you'd like to start chewing through those. So thanks very much indeed, Gabriel. Much appreciated. So if I can invite Amer Karabegovic to join the stage. So Amer's the sales driver, Den, and sales manager. We'll talk about improving heat network efficiency through effective balancing and control. And Amer's from Danfoss. So did you just want to kick off? I'll check your microphone's working.
Thank you, Simon. I hope you hear me. Yeah.
Brilliant. Excellent. Thank you.
Thank you. Good afternoon, all. I apologize, my voice cracked today, but I hope it will hold up until the end. And also, you have one more non-native English speaker, but and I apologize in advance for the, I will say, maybe strange accent for you. But as the people say, pictures speak louder than words. So what we're talking today is improving heat network efficiency through effective balancing and the control. But before effective balancing and control, let me first to say a couple of words about system efficiency as a main goal of heat networks performance. The first condition is to understand what shapes a heat network. And it all starts with buildings, with heat consumption, which needs to utilize resource optimally. Understanding the buildings enable us to simulate networks and minimize transmission loss, which in the last stage is the input for optimum energy sources management, where we save primary fuel and the maximum energy efficiency. There are two additional areas, legislation and the market drivers, and all 5 areas listed here affected the efficiency of the system, each in its own way. So how to increase efficiency? What are the main sources of operating cost optimization? How to define potentials for increasing efficiency? Here you can see I try to put everything related to all these 3 topics, but maybe it's better to go to the next slide there is, I will say, the more clear picture about system efficiency. And we can say the system efficiency involves reducing the energy demand to perform a given task, such as upgrading equipment or implementing energy-saving practices. Demand side management, on the other hand, involves managing the demand for energy by shifting or reducing energy use during the peak period. So you can see a lot of areas, a lot of different sources of losses are present and can be reduced. Now back to the topic, what is a control of heat network? Control of heat network refers to the processes and the system used to manage the heat generation, distribution, the consumption of heat within centralized heating system. The objective is to ensure efficient, reliable delivery of heat to end users while maintaining optimal energy usage and cost effectiveness. So you can see here the 5 main, I will say, topics and the part of the control of a network. We are talking about monitoring and automation, demand matching, pressure control, temperature regulation, energy efficiency. In the previous presentations, we could heard about each of them. When we're talking about balancing, so what is the balancing of heat network? It refers to the process of ensuring that heat is distributed evenly and proportionally across all connected users, regardless of their location in the network. And the proper balancing is crucial to avoid issues such as overheating in some areas or underheating in the others. So what are the benefits of the proper balancing of the heat network? We can have here energy efficiency, so it reduces energy wastage caused by overheating or unnecessary pumping. User comfort, ensure that all users in the network receive adequate heating. Extended equipment lifespan, people forgot about this, so prevents wear and tear on the pumps, valves, and the boilers due to excessive demand or pressure fluctuation. And the end cost reduction, so lowers operational cost by optimizing resources usage. What about methods? So we have 3 basic methods for the balancing of the heat network: hydraulic balancing, thermal balancing, and dynamic balancing. So hydraulic balancing is just adjusting flow rates in the pipes to ensure that all parts of the network receive the current amount of heat. And we, for this method, use valves or automatic controllers in the substations on the network to regulate flow rates dynamically. Thermal balancing is ensuring consistent supply temperature through the network. And here we're talking about utilization and the managing the heat exchanges and mixing controls to avoid temperature deviations. And the end, I will say, combining hydraulic and thermal balancing, we come to the dynamic balancing. It is about real-time adjustment of both flow rates and temperatures using smart and advanced technologies. On the next slides, I would like to show the necessary step for effective balancing and the control. The first step should be, or where to start, is a complete and a comprehensive system analysis. In addition to the analysis, this step checks whether additional measurements need to be introduced into the system. So what we are doing here, we are calculating and validating correct design and optimal dimensions, simulate different what-if scenarios in relation to the heat source, network layout and dimensions, type of buildings, connections to the network, and also detect of bottlenecks and required places for the control and the balancing. Also, the recommended number of measurement points in relation to the length of the network is also shown here. So in the case that we figured out that we need additional measurements, here is, I will say, based on the lot of implemented projects, some KPIs which you need for the additional measurements. The next step includes the integration of all measurements in one place and the possibility of remote monitoring and the management, as well as possibility of benchmarking. Here is very important is emphasis on the one place, so it needs to be unique database, cleaned up, and reliable for further usage. In order to achieve efficient balancing, solutions are necessary that enables this both on the grid and at the heating substation. Of course, remote monitoring and the management of these solutions is required. You can see on the left side, we are talking about optimal control of flow and the temperature, also at lower demand. And it is mostly done by autonomous optimization of different pressure in the substation. On the right picture, we can see how to make flow according to required delta P, pressure drop or pressure drop according to required flow. And we're talking here about remote adjustment of the threshold pressure in the network or in the substation. Ultimately, all the steps taken so far must be integrated into single solution that enables efficient control, system tuning, and optimization. So as I mentioned before, everything is starting with acquiring data from the energy centers, from the network, from the end users. Then we here have also local climate data and weather forecast, and everything is going in. I've now advanced machine learning and artificial intelligence tool, which can provide heat load forecast, so required heat for the couple of days ahead. And based on that, we are doing optimal production schedules and the temperature optimizations. Everything in order to have, I will say, efficient performance of entire heat network. And finally, I would like to show what a system setup could look like in order to have sustainable energy carriers in the most optimal production mix, efficient distribution, and integration, efficient energy use at application level, building, industry, office, commercial building, etc. So, as I mentioned from the beginning, everything is starting from the buildings and the heat consumptions and moving ahead to the energy centers. So, that's all from my side.
Very much indeed, Amer. A very interesting presentation. If you can stick around for the Q&A at the end. Can I now ask Andrew Brown from Bollfilter to come to the stage, please? Andrew was the technical proposals engineer, and we'll be talking about the importance of filtration in heat networks. So we'll give Andrew a couple of seconds to join.
Hello, you hear me?
Hey, Andrew. Yep, you're on, and I can hear you, so I will pull off the stage and leave you to it.
Lovely, thank you. So afternoon, everyone. I'm Andrew. I work for Bollfilter, and I'm here to talk about the importance of filtration in heat networks. So I just wanted to give a little bit of a background about the company that I work for, put a face to the name, if you will. So it was established in June 2000. So since that time, we've focused heavily on the water and wastewater industry. In that time, we've supplied about 2,700 filters. So if you do the maths, it's about 100 filters a year, there or thereabouts. We do also supply to the marine and manufacturing industries, but they're not so big industries in this country compared to water and wastewater. So since 2019 as well, we've become a wholly owned subsidiary of Bollfilter, which is a German company. And since that time, we have had a real drive to expand on new applications using the knowledge that we have already from water and wastewater. So we really pride ourselves as well on the sales support that we give. So we don't just sell filters. We're involved at the very beginning of system design. So we're speaking with design consultants and just ensuring that the system they're designing has an optimal setup with consideration of the filter that we are offering. And just a little bit about live project values for Heat Network. Filtration systems alone, we're around about 890,000 that we've got in live projects. Now, I'll give a bit more of an insight on that later on, because it might look like a small number, but when you consider the amount of solutions that we are offering, it all adds up. So going on to the filters that we offer. So this really is our bread and butter, the automatic filter. So essentially what it is, it's just well, not just, but it's a filter that will clean itself depending on variables such as differential pressure and timer. So as the filter's doing its job and the elements start to block up, differential pressure increases across the filter and the filter cleans itself. So it utilizes the pressure that is available at the outlet of the filter to create a high velocity across the element, which dislodges any debris that is inside that element and sends it to waste. So there's three main elements. This aqua bowl that I'm showing you here, this is our latest design iteration of the automatic filter. This was released, I think, in around 2018, something like that. I don't know off the top of my head how many we've supplied, but yeah, like I say, probably the majority of those 2,700 that we've supplied in the last 20 odd years, they're fundamentally the same design. And that is that design in the middle, the filter candle element. Now for water source projects, this filter type is for open loop, and we would normally offer either the filter candle element in the middle or the fine sieve cylinder element on the left. Let's see. This is just a brief overview of the industries that we offer these filters to. They're doing the same job really. It all depends on where the water is coming from though. Obviously water treatment goes through several different processes and then gets to our filter, maritime, just seawater, and then HVAC and district heating. Could be river water, could be seawater, could be reservoir. In some instances, data centers using the water that's come from the cooling line, just to filter that. This is a bit of an overview of how the filter fits into the system. So, like I just said, where you are extracting the medium from, it could be river, could be sea, could be reservoir, but fundamentally the filter is just there to protect the downstream equipment. So you have heat exchangers or heat pumps, and the grade of filtration typically between 100 and 500 micron, although that really depends on the advice that we get from the manufacturers of that downstream equipment. So when we work with clients, we'll have a bit of a three-way conversation with the manufacturers of the equipment just to determine that the solution that we are offering is suitable for that equipment. So we will size these filters based on a few different aspects. You've got flow rate, which is the big one. You've also got filtration level. The finer you go, the bigger the filter will need to be. And then also the water sampling data. So in some instances, if you're taking the source from the sea, for example, the filter with standard stainless steel internals might not necessarily be suitable. So we would offer super duplex internal, sacrificial anode, that sort of thing, just to make sure that the filter lasts its design life, which is normally around 25 years, providing that it's maintained correctly. Now, with this in consideration, I'm just going to show you a case study that we have. So this is Heatweb Art Gallery, which is in Wakefield. We supplied 2 filters to there in 2012. Now, I spoke a bit earlier about the value of current projects that we've got going through. Now, in 2012, this supply was just under £20,000. So we supplied 2 filters for just under £20,000. Now, the job of these filters is to protect heat exchangers. So they're taking water from the river Calder. In the first instance, there would be some type of screen to take out large debris like branches, and then our filter is there to protect the heat exchangers to 500 micron, which will lengthen the life of those heat exchangers and take the maintenance burden off of those heat exchangers. So I say that it's the purpose of providing these filters is not to move the maintenance burden from a heat exchanger to the filter. Now, it would be cheaper in that instance to do that anyway. It's much cheaper to take a filter apart than replace heat exchangers. But we aim to provide a solution that is going to increase the lifespan of the heat exchangers and also not cost the customer or the end user in the long run on maintenance costs. So yeah, just a photo there showing the setup. So this is these are the 2 filters that are servicing the heating and cooling of the gallery. So at the gallery, a lot of the artwork needs to be kept at a specific temperature to make sure that no damage occurs. So really, those filters, they have a crucial role in making sure that the system doesn't go down. Now, there's the lovely chap at Hepworth, Alan Lovett. He has got nothing but good things to say about these filters, and I think it really shows how, having that small investment in the first instance can really benefit the operation of, whether it's the gallery or it's district heating scheme for houses or something like that. It reduces ongoing capital expenditure. They don't have to worry about replacing their heat exchangers as often. And this is a very good application for people to go and see. Alan is always happy to show people around. He might as well be wearing a Bollfilter shirt because, like I say, he just likes showing other customers around. So if you ever get a chance, that'd be a good one to go and see. We have got a full case study of this. If anybody's interested, we can send it across. And this is a bit more information on other applications for district heat networks. We've got heat from mine water. There's a project we were working on earlier this year up in Seaham. They're taking it's mine water filtration, but also protection of a drinking water source. So it's sort of hand in hand with what we do, what we already know, and what we're sort of progressing in. But we had a lot of conversations with the client, looking at water sampling data and whether our standard offering is suitable. So we ended up supplying 2 filters with super duplex internals for protection of heat exchangers, and also downstream water treatment equipment. So that's really crucial. And then the second one there in the bottom right is heat from wastewater, which it's taking final effluent using the heat from that for tomato growing or strawberry growing. We've got a few filters set up in these applications. So really interesting stuff. It's the filters all do the same job. It's just protecting downstream equipment, making sure that you reduce maintenance costs and reduce maintenance burdens from the more expensive equipment. So yeah.
Brilliant.
I think that's it, really. Yeah.
That's great. No, absolutely. Thanks very much indeed. Much appreciated, Andrew. Thanks very much. So if we can now invite Paul Barnard to the stage. Second to last presentation. Paul is the technical sales engineer from IWTM. and Paul will be presenting on the water margin. So, yeah, very intrigued to understand what the water margin is. Paul, did you want to just say something? Check your mic's working.
Yeah, good afternoon. Can you hear me?
You're quite quiet. Could you put the microphone a bit closer to you?
Is that better?
Yeah, just speak quite loudly.
Yeah. Okay. No problem.
Brilliant.
All
Thanks
right.
so much.
Thank you. So good afternoon, everyone. Thanks for staying with us. I know we're in the graveyard shift now. So yeah, as Simon said, my name's Paul. I'm from IWTM, and our company specialise in chemical-free water treatment for closed-loop heating and chilled water networks. I chose to, for those of you sort of old enough to remember, as old as me, you remember a program called the Water Margin, which is the title I chose for the presentation. Everything we talked about today has been about optimizing heat networks, maximizing their performance, and optimizing these networks is all about marginal gains in efficiency and performance. And water is increasingly becoming an important commodity, and the water quality in the lifeblood of these heat networks is very important, because all those marginal gains in the clever designs, in the decarbonisation, in the lower temperature, can be lost if the water quality isn't delivered and maintained to the correct standard. We know that even 1 millimetre of debris or scale in the system can lead to performance inefficiencies in terms of heat transfer across plate heat exchangers, pumps having to work harder because they're pumping more sludge and slurry around the network than what's required. So yeah, presentation is to try and quickly run you through how chemical-free water treatment can deliver the best outcomes to all stakeholders in the life cycle of a network. So just a quick word about the standards driving chemical-free water treatment in heat networks. So the VDI 2035 standards, if you're not familiar, is the equivalent of the German Association of SIBSI. So back in 2009, they did research into the causal elements of corrosion within closed-loop systems. And they found that by effectively, if you control your dissolved oxygen, your pH and your conductivity to strict levels, you can move water into a non-corrosive state and remove the need for adding inhibitors, biocides and so forth to prevent corrosion. So this practice has been adopted and written into EN 12828, so it's the European standard for water quality treatment. You'll find that we talked about how we've looked to sort of Denmark and mainland Europe for other expertise, that the Danish District Heating Association have adopted this in their approach. The Germans have. SIBSI have now written us into their heat networks code of practice as an alternative method of water treatment. And actually you'll find a lot of the HVAC manufacturers that we install onto heat networks, be it in the energy centre or in the end user's apartment, have the VDI 2035 standard as their preferred water treatment methodology. So the triangle you see on the right here is your key sort of parameters that chemical-free water treatment is looking to control, and that's your dissolved oxygen, your pH, and your conductivity to these levels. So how do we do that? So just very quickly, whatever size network you have, we've got two core products that would sit on the network. We've got what we call a demineralizing unit or resin filtration device, and this is there to sort of manage and engineer the fill water into a desired state by removing your salts, limes, chlorides and minerals out of the water through an ion exchange resin bed. And the second piece of equipment or core product that sits on the network would be what we call a reaction tank. And this utilizes the science of electrochemistry and sacrificial magnesium anodes to constantly clean and maintain and optimize the quality of that water through the network life. So just a quick word about how those two bits of equipment work. So the demineralizing unit, this is made up of a a mixed resin bed, so applies the science of ion exchange resin. So your raw water, any makeup or fill water to a network is passed through this resin bed, and this resin bed strips out all your salts, limes, chlorides, minerals, sulfates, nitrates, and replaces them with hydrogen and hydroxyl ions. It also takes out the dissolved carbon dioxide out of the water, which when left in can become carbonic acid and drag pH down. So this controls sort of two of those key parameters in terms of the conductivity of the water and tweaks the pH. Now the conductivity is important in terms of low conductivity water basically restricts pathways and processes in the corrosion process. So by lowering conductivity, we slow down all the processes of dissolved oxygen, for example, reacting with the metals and causing corrosion. In terms of where we're installed in the network with the demineralizing unit, this is installed permanently on site before your pressurization unit and before any quick fill loop, to ensure that any makeup water that's pulled into that network in the future is controlled in terms of its water quality and conductivity. And you'll see a little sort of on the outlet of what we call the protector profile unit. There is a meter which is measuring the conductivity of the treated water, and again this can be fed into a BMS system to give visibility on when sort of resin may have expired or need to be changed. The second piece of kit that will sit on the network to sort of deliver this solution is what we call the reaction tank. Looks a little bit like an air separator and is sized around the system volume of the heat network. And central to this is sacrificial magnesium anodes. So magnesium is your least noble of metal, which means it will corrode and give itself up ahead of any other host metals within the network. And its primary functionality is to scavenge and control any dissolved oxygen that's in the makeup water and control that down to very low levels. Generally speaking, any makeup water has 9 to 11 milligrams of dissolved oxygen in it, and we're looking to control that down to less than 0.1 milligrams per litre. So as the water passes through the unit, it reacts with the anodes. The anodes burn through the dissolved oxygen, control that down to a low level, and as a result of that reaction, the magnesium with the oxygen, you produce magnesium hydroxide, which is a natural pH raiser or buffer. So this means we will generally settle out between 8.2 and 10 in terms of pH, which is a happy place for most of your metals, and will also sort of help to prevent any bacterial growth within a network, because they don't generally like the higher pH. Generally speaking, as we chemically change water by adjusting dissolved oxygen and pH, water wants to return back to its original state, so it can hunt out any debris, any corrosion that might have taken place around the network, and we'll bring that into suspension over a period of time. And so our unit's secondary function is it will act as a side stream filtration device as well. So it's got a micron basket in there to filter any particular out. As the water hits this unit, you get what's called cyclonic filtration. So microbubbles of air are vented through the automatic air vent. There's a hard magnet in there to catch your magnetite. And then the unit can be isolated, blowdowns can be carried out to get the debris out of the system as part of your sort of normal PPMs. In terms of installation of this unit, this is normally installed sort of on the hottest part of the system to help sort of vent the air out on side stream. So we manage the flow rate through the unit and ensuring we see a system pass of water over a 24-hour period. Just in terms of a case study to give you an example of a scheme, a sort of heat network we were installed in, and some of the challenges that we were faced. So this was a new build system, sort of 540 meters cubed sort of system volume. And the challenges in delivery, there were two contractors on this site who had two approaches, and we had two sort of outcomes from that. So one contractor was sort of delivering the energy center, and one contractor was delivering the distribution network. And in terms of the energy center, they'd done their pre-con fill and clean sort of using a closed loop CPC method, and had hit all the correct levels in terms of meeting the VDI standards. On the distribution side, it proved more challenging. They'd used a different methodology in terms of sort of ice pigging, and some of the valves had not been had been shut off, and this meant the quality of the water on that side wasn't at the correct standard. But program meant that the two had to be joined together without being able to clean the other side of it. But one of the benefits of our technology was that, even though that was joined together with incorrect levels, we brought the condition of that water was brought into the correct levels under normal operation without any costly interventions. One of the other reasons for selecting this approach on this scheme was chemical-free water treatment is suitable for situations where you've got low and intermittent flow situations. So because there was going to be a number of dead legs on the situation, because people were going to be brought into the system at later dates, because we move water into a non-corrosive state, we can sit dormant in the pipe work. We're not reliant on circulation in the same way you are with chemical treatment. And finally, sort of delivering, the contractor had an energy performance contract on this site, which meant they felt that our OPEX costs were beneficial in terms of them being able to deliver that system. Just two more slides and I'm done.
Yeah, okay, Paul, if you could wrap up in the next 30 seconds, it'd be great.
Yeah, no problem. We've talked a lot about real-time monitoring and the importance of being able to ingest data from the system. So with our technology, we have real-time monitoring options where we can monitor those key parameters for chemical-free water treatment in terms of dissolved oxygen, pH, conductivity, pick up the galvanic current from the anodes, the system temperature, pressure, and differential pressure across the filter, so that all that information can be fed into a BMS and give visibility and real-time reporting on your network. So,
okay, thanks, Paul. I'll have to cut you there because
no problem.
We need to get the final speaker up and running. So thanks very much indeed, Paul. Much appreciated. I see Steve's joined us. Paul Tuesday went for the question and answer. So, final speaker, Development Director Steve Hunt. You've heard the rest. Now is the best, Steve. Come on, I'll give you a big one.
That's the big one, Simon. Can you hear me okay?
I hear you perfectly. So beyond the contract, optimizing heat networks for customer success. Over to you, Steve.
Thanks, Simon. And it is the last one, so hopefully everybody bear with me for 10 minutes. And it's a slightly different angle to what has been previously said over the last 2 or 3 hours. So that's a nice way to finish, hopefully, that we're not talking in contradiction or against anything that's already been said. So we're Ener-Vate. I'm Steve Hunt, Director of Ener-Vate. And what I want to talk about today really is all the things that have been discussed so far and how it actually gets to be benefit and how we manage that benefit long term. So straight on to the next slide, Simon. Let's have a look. There we go. So, as we've seen, and as I've heard, there's plenty of expertise around in our industry, and none more so than now, actually. There's so many people delivering good products and good services in our industry. And there's a lot of effort made to ensure that design and installation and everything else is carried out to the highest degree. And I think we've come a long way in the period that I've been involved over the last 10, 15 years in that regard. But our sort of experience and how we interact with the industry through Ener-Vate is we come at it from a slightly different view from the client and what they see. And a lot of times they are the problem half the time. So it's coming at that angle and making sure that the expertise that we've heard this morning is providing the actual benefit that we want as an industry. Okay, who's actively managing these contracts going forward? Now, we all have our contracts in place with suppliers, of course. We all have our contracts with clients that we carry out, but many times those contracts are delivered, personnel move on, client personnel move on, and the actual monitoring and KPIs and all that that's involved in that sort of gets diluted and is not actively managed and maintained. And so therefore the system isn't performing to efficient levels and so on. The main problem, as I've just mentioned there, can sometimes be the end client and having consistency in who you're talking to at client end, and personnel changes within client, of course. So there is a big gap there that Ener-Vate filled to a certain degree, but there's obviously a much larger gap than Ener-Vate can ever fill. And on top of that, if there is a disconnect between what we are doing as an industry and the client, there may be even worse communication being done at user level. So if the client is not informed properly, then the message isn't getting through to the end users. They come with problems that need solving, etc., and things can snowball pretty quickly. So I've only got 10 minutes, so I'll whip through this very quickly, Simon. One of the things I always ask is, whenever you talk about heat networks, the public perception of heat networks, generally, why aren't they clamoring to be connected to one? Why is it always almost a resistance? Why is, I'm talking here as an industry here, why do we need to justify ourselves all the time? Why is it something that we're not being advised and encouraged to be connected to as the public? And it generally comes through misunderstanding, miscommunication, inexperience, and so on. Obviously, there's a louder noise made with poorly performing networks than good performing and well-performed networks. So the customer experience generally of heat networks, not all, obviously there are very good heat networks out there. The service levels that are provided generally haven't been as well delivered over the years as they should be and could be. And certainly not as well perceived as other network providers, gas and electricity. And I want to know why. Why is that? Where's that concentration of what we need to do for the customer? As I said, lack of expert understanding by the owners and the operators goes a long way to providing this problem. And the lack of service levels over the long term. Everybody sets out with the right intentions, but over the long term, these things get diluted. And I do think, as an industry, we have placed a lack of importance on the expertise required over the long term to manage heat network post-installation and post-design. With all the best intentions that have been described over the couple of hours this morning, there it is. It's a great performing heat network, but in 5 years' time, who is actually looking after that for the longer term? A very lazy analogy, bear with me here. My dad actually a long time ago said the best thing you can do is have great tires on a car, because essentially that's the only thing that's touching the ground. So all the design of the car is absolutely no use whatsoever if the tires are not performing, if it's sliding everywhere. The only thing that actually connects the technology to the actual area that it's working in are the tires. So making sure that the tires are right is absolutely important. All the design expertise that we've talked about this morning, all the technical advances that we are making as an industry, they're no good at all if the end users are neglected, if that communication is neglected, if there isn't a clamour from the public to use our services and our industry. So it's a question really open to the floor about what we're doing as an industry and how can we improve that communication piece, as well as the superb technical and management pieces that we have within our industry. How is our industry liaising with the public and changing their view? So if we are to provide 20% of the UK's heat, which is often stated as the aim, then we must create a culture that creates that demand. You know, otherwise we're just pushing the ball up the hill all the time. We're trying to justify ourselves at the time. It's all hard work. If we had a clamour to be connected to heat networks by developers, by retro users, I want to be connected to a heat network, etc., and all the regulation that's coming in, all the zoning that's coming in the next year or two, that's helpful, of course. But if the public was clamouring to be connected to one, that is also a huge benefit to the industry, making sure that there is a need from the public, there is a clamour from the public to marry with the legislation that's coming in and the regulation that's about to drop. So we need the benefits of all that well-designed and operated heat networks that we've talked about today to be understood by our clients, our global clients, I should say, and also, importantly, the end users. This will only come with greater emphasis played on good operational management, good communications and service levels over the long term, that people can say, I'm connected to a heat network and it's great. So that's my final angle to sort of sum up the day, really whip through there in a few minutes only. Obviously, EAMS provide this service that I'm talking about, of course. That's why I'm on here talking about it. But there's obviously others out there that do as well, and it would be a benefit to us all if this service and this point of our industry is really taken forward and some concentration placed upon it. So thanks, Simon, for the opportunity to say that slightly different message to the rest of the speakers, and I will finish there.
Brilliant. No, thanks very much indeed, Steve. That was a really, really interesting presentation. I love the bit about the tyres in the car and making sure you got good tyres on your car.
Yeah.
You're absolutely 100% right. Brilliant. Okay, Tom, if we could pull down that presentation, and if I could invite Paul, Andrew, Amer and Gabriel to come back. We've got a few questions in the chat. So Gabriel, should we start with you? Hopefully you've seen the questions. There were two questions for you, Gabriel. One was about the size of the gas boilers versus the biomass, and the other one was about whether you covered resident engagement as well as part of your commission at all.
Sure. So yeah, the first question around the gas boilers, they were the original. Well, I don't know if they were the final original, but they were boilers installed within the last 25 years. Actually, there were 3 rated at 3 megawatts. So the installed capacity at that energy centre was some 9 megawatts. So I guess they were expecting a 6 meg peak at some point. That has been reduced down over time. I think we see roughly, I mean, it's running at the moment about 2.5, but we do see beasts from these kind of levels probably hitting up sort of 3 and just above. Most of that is dealt with the thermal store, and the biomass boiler sees it right through. The reason why we kept the 5, so we derated all 3 boilers, put new burners on them to 1.5 megawatts each. So we reduced 9 megawatts of boiler capacity to 4.5 because we couldn't go much lower with the gas burner conversion. So that was the reason for that. But that will see, they will be looking at them at the moment in terms of their asset life and what the approach will be going forward for replacement of those. So sizing will be addressed again. I guess the next question was the engagement. Yeah, I mean, it's a difficult estate. It's had its issues over the years. It's got a lot of people live in Dufferin Estate in the 970 dwellings. Not sure how many, but a few thousand. And the engagement, they've had a number of projects run over years. Metering and billing, putting the metering and billing. They went from a pay per week, open your windows to regulate your temperatures kind of method to a pay for what you use process. That was had different levels of popularity by those 2,000 odd residents, and I think they used to write to the papers and complain about one thing or the other. I think when we moved, the main difference in our engagement was taking out the hot water cylinders, installing the HRUs, changing all the radiators. We had to make the case of why that was going to be better for them. The meeting was done beforehand, and then the HRUs and radiators came. Of course, we're trying to drop the temperature, so there's a lot of tenant liaison around how we wanted the temperatures to feel cooler. That the bottoms should feel cold. That was the plan, and that would be more efficient, and that would reduce their costs. That took some time. That message took some time to get through. Lots of complaints on radiators aren't hot enough. They're broken because the bottom's cold. So we sent out, the utility homes would send out leaflets and try and explain that was keeping their costs down as much as possible if they could understand that principle. And that's sort of where we got to. But yeah, challenging process from all different kind of angles.
Okay, no, that's great. Amer, I'm conscious there was a question for you which you kindly responded to. Is there anything more you'd like to say about that
Yeah, maybe just to distinguish here two things. So when we are talking about this load forecaster, we can, I will say, place at the level of the entire system, but also we can place it at the level of the building and then connect it to BMS. So, but when we're talking about heat network efficiency, we want to have the calculated heat demand required hourly basis for the, I will say, 5 days ahead to be ready to plan our production, to plan our different sources, to make in terms of change the fuel, change the capacity and the sizes. But also it's possible to apply such advanced tool on the buildings level when based on the just from the data from the heating substations, for example, heat meters, and some additional sensors inside of the buildings, we can again make, I will say, the same things at the buildings level.
Okay. No, brilliant, excellent stuff. Andrew, quick question for you. I'm going to make sure you all have a question. What particulate size? I'm personally working on a project in my non-UKDEA life with an incredibly muddy, dirty river. What particulate size can you filter down to with your filtration systems? Just intrigued to understand where the market is.
Yeah, so depends on the element type really. So the three element types that I showed on the presentation, you've got you've got a core screen which can have an element size of 2 millimeters, 3 millimeters, or 5. The candle type element which we supply probably 95% of the time, it can go down to about 100 micron, so from 1 millimeter to 100 micron. And in some instances a bit finer than that. And then the fine screen element is down to 10 micron.
Okay, cool. Excellent stuff. We've had some questions about chemical-free water treatment and whether it's suitable for mixed metals, and you've answered that, so that's good. Alan Rocker has put a question, Paul, in the Q&A about comparisons between your types of systems and traditional systems with side stream filtration and chemical biocide dosing. I'm conscious we've got about sort of a minute for a response maximum. Is there anything you can say in that minute about comparison in costs?
I mean, we should be cost positive against them. The theory behind chemical-free water treatment is we create an environment that is hostile for the bacteria to grow. So by scavenging their food sources, i.e. the dissolved oxygen, maintaining higher pH, removing the biofilms and food sources for the SRBs and the NRBs, we create that environment and remove the need for sort of costly inhibitors and biocides. So,
okay.
Yeah, a better approach.
Good. Okay, brilliant. Thanks very much. Steve, I loved your presentation. I thought it was really good. I think maybe you'd stunned people into silence. Can I ask you, what do you think is the biggest challenge facing heat networks? It was a question we asked in the previous section. So if you just thought about the #1 challenge facing heat networks over the next 5 years, what do you think that would be?
I can answer that relatively simply, I think, maybe too simply, Simon, in that, do people want them? You know, we as an industry, you know, we are doing everything we can to make them better, be better managed, to explain to a certain degree, to design them, to install them. All their effort is going in. The government are putting their weight behind things, you know, as we've seen. Do people want to be connected to them? Generally, no. Why? Why don't they? What's the resistance? What is it that's giving that resistance to being on it? And I think that's what I'm trying to get to say, if we have all the expertise that we have in the industry available, or the government support that we're getting, and we'll have the regulation that's coming in, what else do we need to convince Mr. Jones, I want to connect to a heat network? What makes him go to his developer and say, I would prefer this house if it was on a heat network as opposed to another system? So it's that really, and I say it's an open question to the industry. What are we doing about it? How can we improve that? How can we improve that communication? And I think long-term, good heat networks, managed well, installed well, designed well, will go a long way towards that naturally, but what else can we do?
Brilliant. No, I think that's a really good, and somebody from the floor has asked that same question as well. There's a final question about, one for Andrew, just very quickly before we filter. If we need to filter river water to extract heat from it, what would you recommend? Using a filter and titanium coated plate heat exchangers, or would you advise changing the chemical composition of the river water as well? Final question, and one for you, Andrew, if you feel you can answer it.
Yeah, I'll give it a go. I don't think I could comment on really, what which is the best way to do it. I think obviously you'd likely look at the capital expenditure costs. What is the more economical solution? But in terms of changing the chemical composition of the river water, do you mean dosing, or do you mean sort of what Paul has been talking about? I think from our point of view, if you go down the route of a plate heat exchanger, really it's what are you expecting? How long are you expecting to use that plate heat exchanger for? When you expecting to replace it, and can a filter extend that lifetime to a point where it recoups the cost of that filter?
Okay, no, that's fine. I will, Mohammed, will have your contact details from the presentation when circulated, so I'll leave you to pick up that conversation online. But I'll refer everybody back to Steve's point, which Jared Bedford has said. Excellent answer, Steve. And I think it's important for all of us. When Ludo Tolu spoke at our last conference at Alexander Palace, they made it very clear we need to create more fans for Heat Network. We need to be presenting in bigger stadiums. So hence why we're planning our Heat Networks Expo early in 2025. We need to embrace the wider audience for Heat Networks and encourage people to connect and want to connect. So a really positive point to finish on. So a big thanks to all of the speakers in the final session, and indeed everybody who answered the call this morning. Thank you very much indeed. Without further ado, I think we'll close the event. Just safe to say, wish everybody a very happy Christmas, and thank you very much indeed.
Thanks, Simon.
Thank you.
Thanks, guys.
Thank you
very much.
Bye.
Bye. Take care. Bye-bye.